Hello my dear friends, welcome to my YouTube channel ANIRUDH'S Chemistry World. Welcome to you all to my channel. Today I am going to teach you and start the chapter called as Structure of Atom. This is the first chapter in your CBSE and NCERT book. This is also there in your same syllabus JE and Neet. So it will help you a lot. I am your master teacher for chemistry, Anirudh. I am also I also teach the subject physics. So I have interest in both the subjects, physics and chemistry. So I opened this channel, chemistry. So please do subscribe, share, and like this channel. And if you have any doubt, please comment me down. Okay, let's start. This is the chapter name. What is atom? The word atom has been derived from the word called as atomio. This is a Greek word. Atomio means it is indivisible. Indivisible is also called as uncuttable. This is the statement given by John Dalton. Dalton has concluded that the atom cannot be divided or is uncuttable in simple words. This is the nucleus. This is the whole structure of atom. Nucleus mainly has two subatomic particles. These are proton, which is a positively charged particle, which is very small, and neutron. Which will be there in nucleus. Right. This neutron is a neutral particle. Means there is no charge on it. These are the shells around the nucleus. Just I am giving the basic introduction of atom. We will see the different models given by the different scientists such as J. Thomson, Rutherford, Bohr, and we will see it later. So first let us understand in a very basic manner. This is atom, and these are called as shells or orbits. In these orbits, electrons revolve around the nucleus in circular paths called orbits. This electron has a mass of electron. Mass of electron is about 9.1. This is very important, kindly note this. You will have many numericals based on this. Mass of electron is 9.1 into 10 to the power of minus 31 kg. Always you need to try to remember in your SI units, that is MKS systems, which you have already learned in units and dimensions. So I will briefly explain when I explain physics. Okay. These electrons are negatively charged particles. Kindly note this so that you will have good visualization skills, right? Okay. Next. Okay. You also note this important point. Charge of electron. These all things you will be learning in the physics chapter called as modern physics. The same things will be there and the numericals will be same. Charge of electron is minus 1.6 into 10 raised to power minus 19 coulomb. The charge is always measured in terms of unit called as coulombs. Coulombs represented by coulombs are represented by letter C. Similarly, the charge of proton is same. The magnitude, this is called as, the negative symbol indicates direction. This 1.6 into 10 to the power of minus 19 indicates, this is called as magnitude. The number without any sign is called as magnitude. Remember this point. So this magnitude of electron and proton is same, which is 1.6 into 10 raised to power minus 19 coulomb. But one thing is that for proton the charge will be plus, right? And the charge of neutron, the charge of neutron is chargeless. It's chargeless, right? As I have already said before. On every chapter, you should at least solve the problems of 200 to 300 problems, and JEE related level, you need to solve some 60, 70 and of each topic, at least 10 of each topic, 10 questions of each topic, so that you can get some good idea. Based on what I studied previously, the note points which I have written after solving that 150 to 200 questions, I am directly giving you. So it's very useful to you to solve these numericals. You don't have to panic, and you can directly go through these points and you can solve the problems. Okay, now I am going to tell you this cathode I am going to tell you about cathode rays. This cathode rays experiment is performed in discharge ray tube, which will be looks like this. This is vacuum pump. Here it will be like this. You can name it as VP, vacuum pump. Okay. Right. This vacuum pump is used to regulate the pressure actually. In this discharge ray tube experiment, you will be having pressure around 0.01 mm of mercury, that is Hg, right? Or you can, in scientific method, you can write 10 raised to power minus 2 mm. Okay, here these are electrodes, right? Electrodes. In electrodes, you will be having two types: anode and cathode. You will be confusing between the two things. I know when I studied, I used to confuse. So I am telling you. So anion is negatively charged, whereas cation is positively charged. Some people will confuse between anion, cation, and anode and cathode. These are opposite things. When you learn this electrochemistry chapter, you will be noticing that anode and cathode will have some different signs. as you don't expect. So let us primarily understand this. Anion is negatively charged, cation is positively charged. So, but anode is positively charged, cathode is negatively charged. So if you understand one thing, you can automatically reverse it. That's it. Okay, here in this, let us come back here. Here in this discharge tube. Okay, I didn't write this. Okay, I got here. Discharge tube. This discharge tube. Here you will be connecting a voltmeter. So you will connect the battery. Here you will supply around 10,000 volts. 10,000 volts will be the voltage you will be passing, and in vacuum pump you will be passing you should maintain the pressure of 0.01 mm of Hg, right? And here what happened is J.J. Thomson has discovered one thing. He observed that when he maintained 10,000 voltage and 0.01 mm of Hg in this using this vacuum pump, he observed something glowing behind anode. Something glowing behind anode. This is nothing but fluorescence. He understood that this is due to some invisible rays traveled from, this is cathode, let us say cathode. The rays have traveled like this. Let us understand by using dots. You consider these dots as rays. These rays are traveled from cathode towards anode, and he found something glowing behind anode. This is called as, these rays which have traveled from cathode, since these are emerging from cathode and moving towards anode, these rays are called as cathode rays. Cathode rays. These cathode rays are invisible, right? And these cathode rays contain these electrons, because he also did another experiment for proving this. Generally what happened is, these cathode rays, I'll write the point so you can note properly. You write like this so you can remember easily for future use. Cathode rays are cathode rays deflected towards positive plate, which proved that since these cathode rays attracted towards positive plate, he proved that these are negatively charged. As we know that opposite charges attract. Since these cathode rays are moving towards positive plate, when he used this experiment, he observed that cathode rays are deflected towards positive plate. Hence, he concluded that J.J. Thomson concluded that these cathode rays are negatively charged. So I'll write the properties. You just note down this. I'll write the properties. Right. These cathode rays have mechanical energy. So you can represent this with ME. It's like a shortcut, and sometimes in JEE CBSE level questions he will denote with ME only. So ME represents mechanical energy. So these cathode rays have mechanical energy, and hence travel in straight line. Since these cathode rays have mechanical energy, these travel in straight line. They travel from straightly from cathode to anode, and this is fluorescence. The same thing you will be observing when the TV works on this mechanism. The fluorescence happens and due to this cathode ray experiment only. Some other things will be there. Let us basically understand this. Next, some gas will be filled in here. Also, I forgot to tell you, here there will be some gas. Okay, we need not worry about this gas. Some gas will be there filled in this discharge tube. So to be ideal, right? So these properties of this cathode rays, I'll write the properties, or you can say this characteristics. The properties are the properties of cathode rays are independent, means not dependent, independent on nature of gas. Nature of gas means the properties of these cathode rays which are traveling are independent, means not dependent on the nature of gas which is filled. You can fill any type of gas, nothing will happen, right? Okay, this is the experiment which I tried to explain, right? Next, you just take a screenshot of it so that you can better understand this, right? Similarly, you will be having this anode rays. Similar to that of the experiment is same, but instead of cathode rays, you will be having anode rays. Anode rays, or these are also called as canal rays. Right, you can remember like this. Cathode rays, which I explained previously, this is anode rays or canal rays. All the experiment and setup is same, but one thing is that here the rays, that is the anode rays, travel from there. The rays travel from, emerge from cathode and move towards anode. Here the thing is reverse, opposite. The rays travel from anode. So since they are emerging from anode, the name is given to them as anode rays. Since the rays are emerging from cathode, the name is given as anode rays, cathode rays. So that you just remember from where the rays are emerging, so that automatically you can remember. The rays travel from anode towards cathode, and move in straight path or straight line. They move in straight line, similar to that of cathode rays. They travel in straight line. But one thing you need to remember is here the properties or the characteristics are dependent. Okay. The characteristics are dependent on nature of gas. Okay, the characteristics are dependent on nature of gas. There in in cathode rays, the characteristics are independent. Whatever gas you fill in it, the properties never change. But here the characteristics depend on nature of gas. Suppose you fill some H2, and after that you fill some nitrogen. No, it will not work. It will change. The properties will change. So, like that. Now, and one more point is that these canal rays deflect towards canal rays deflect towards negative plate, because one simple logic, anode means what I told you previously, anode means positively charged. These positively charged rays will always travel or always deflect towards this negative plate. So hence he concluded this experiment like this. So it's mainly important, it's not most important for your JEE, but it's more important for your CBSE or some state level exams. Right? Like your board exams. Okay, take a screenshot of. Previously, before 18th century like that, the people only gave the visualizing based upon their ideas. They gave the atom will be like this, like that. No, it's not like that. After 18th century, so many scientists like Dalton, Rutherford, J.J. Thomson, Bohr, they all changed this structure of atom. And after that, you will be seeing this quantum mechanical model. I'll teach you in the further, right? Now, how discovery of neutron. Discovery of neutron. I previously told you that these neutrons will be there in the nucleus. These are chargeless particles. This neutron is, first I will tell you and then I will write so that you can understand better. This neutron is produced by bombarding the alpha particle, bombarding the beryllium in presence of alpha particle, right? And it produces carbon along with the chargeless particle called as neutron. I will write the reaction, you kindly note this. Beryllium, the atomic number is 9. The 9 is atomic mass. Beryllium bombarding in presence of helium, that is alpha particle helium-24. The atomic mass of helium is 4. Bombarding the beryllium in presence of alpha particle, it gave carbon. Always you remember, atomic number and mass number cannot be destroyed, neither be created nor not be destroyed. So according to this, 4 plus 2 6, like atomic carbon atomic number is 6, hence it is verified. Now it's 13. No, it's if neutron will have mass, so it will be 12, and since neutron is chargeless, it will not have any atomic number of charge, so but it will have some mass. So 9 plus 4 13, 12 plus 1 13, hence it is verified. According to Dalton's theory, mass can neither be created nor be destroyed, hence it is proved. Now we will be starting the models, atomic models. Atomic models. In these atomic models, you will be having, first one is J.J. Thomson, who discovered this canal rays also, which I told you previously. J.J. Thomson. The atomic model, first model you will be having J.J. Thomson model. After that, you will be having this Rutherford model, third atomic model. After Rutherford model, you will be having Bohr's atomic model. Okay, after this, you will be having the atomic model which is running now presently is quantum mechanical model. Quantum mechanical model. Okay, these are the atomic models we are going to deal with. Right, you just note down this. So first we will be learning about this J.J. Thomson model. wrote it down previously, right? So I'm erasing this. J.J. Thomson model. I'll draw this diagram for your better understanding. J. Thomson proposed that this atom, according to him, the atom is spherical in shape, but this is a positive sphere. This is a positive sphere. Positive sphere. This is a positive sphere, and he told that in this positive sphere you will be having electrons. Electrons are embedded inside this positive sphere, like this. I will be drawing. This negative indicates that these are electrons. Electrons. Here you will be having. If you see in your book, NCERT book, you will be having full of it's colored with yellow color. So it's better for your understanding. Now these are electrons. Electrons are symbolized as E minus, and proton is symbolized as P plus. Neutron is N. Since there is no charge, we don't indicate the sign. This is atom. This Thomson model also have another name called as plum pudding model. Plum pudding model. Exactly, if I tell you, imagine the watermelon. In watermelon, you will be having the red part. Imagine as the positive sphere. Watermelon is not spherical, but for your understanding, you just imagine it as a sphere. And in watermelon, this red part will be there, right? This is a positive sphere, and the seeds which will be there, that are, you take it as an electrons. This is a good example so that you can understand. This is also called as plum pudding model or a raisin pudding model. You can give different names. I will write the conclusion of this model. Yeah, you just note it down. Atom is spherical. Atom is spherical in shape. First point. Next, atom is having full of positive charge in which electrons are embedded. Means embedded means they are inside the positive sphere. So electrons are embedded like this. And one more thing, this has, I already told you, this is called as plum pudding model. In JEE and other competitive exams, he may ask, other than J.J. Thomson model, he may tell you about plum pudding model. Which of these models is also called as plum pudding model, and you will be having also another name, raisin pudding model. Raisin pudding model. And sometimes it is also called as watermelon model, right? Okay. The drawbacks. Let us write this drawbacks. Drawbacks are as important as exceptions in chemistry. In chemistry, the main questions will be drawn mainly in the part of inorganic and physical chemistry. He will lift the questions from exceptions. These exceptions are very important. Now I am writing these drawbacks. Drawbacks are also as much as important like those. Right? So drawbacks. Drawbacks means by doing what he failed. Drawbacks. Drawbacks. In drawbacks, first for drawback, there is only one drawback. One drawback, that is, it failed. After Rutherford model Rutherford model, which proved atom model to be quite different. It's completely different, and also he couldn't explain the stability. Jeeadvanced couldn't explain the stability of the atom. Moreover, it is completely different and outdated like that. After Rutherford proved by doing his alpha scattering experiment, so which proved that nucleus will be very small when compared to the atom. Suppose if I hold the ball in hand, this is nucleus example, surrounding it till 5 kilometers radius, that will be the atom. Means nucleus will be that much small as compared to atom. So just note on this. Okay, first of all, before going to this Rutherford model, I am going to tell you this atomic mass and the symbols and representation of the element. First, atomic number. In your lower classes, atomic number. In your lower classes, you have been learnt about this atomic number. In atomic number, in 9th class and 10th class, you dealt with this atomic number. In atomic number, you learned so many elements. But in this 11th and 12th, in this 11th, 12th period and JEE journey or some Neet journey, you will be learning most of the elements in the periodic table, which are divided into some different groups. Atomic number, this is represented by Z. So, okay, if you understand like this, you just represent it like this, Z, simple Z, or some people will call as Z. So, yeah, I left to you. So, atomic number is represented by Z. Atomic number is defined as number of protons in nucleus. This proton, this atomic number is nothing but the number of protons in nucleus. In case of neutral elements, neutral elements like when no electron is removed or no electron is gained, in that cases, or in most of the cases, the number of protons in nucleus is the definition for neutral elements in this atomic number. And also number of electrons as symbolized with E minus. So number of electrons in atom, the number of electrons in neutral atom, that's the word, keyword. This neutral is a keyword here. Number of electrons in neutral atom is equal to atomic number. Okay, is equal to atomic number, which is Z. I write like Z like that, so I wrote, see, this is Z. So basically, first of all, I need to teach you this some 20 elements, which will be enough to understand these 4 or 5 chapters which were there till states of matter. This states of matter is related till chemical bonding, you can understand better. In 20 20 elements, first 20 elements I will write like this. The first element is hydrogen, symbolized by H. Second, okay, I will write like this: 1 hydrogen, 2 helium, 3 hydrogen, helium, lithium. Next beryllium, 4 beryllium, 5 boron. Remember, hydrogen, helium, lithium, beryllium, boron, carbon, 6. 7 is carbon, nitrogen, oxygen, fluorine, neon. First 10 elements I will write so that you can understand. 1 hydrogen, 2 helium, 3 lithium, 4 beryllium, 5 boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, 10 neon. Next 10 elements. Okay, I'll erase this. Next 11, sodium. 12 is magnesium, which is represented by Mg. I suppose you, I think most of you know the symbols. Okay, if you don't know, just go through this. This Na means sodium, Mg magnesium, aluminium, which is 13, 14 is silicon, 15 is phosphorus, 16 is sulfur, 17 is chlorine, phosphorus, sulfur, chlorine, 18 is argon. This argon is a noble gas. Noble gas. 18 is argon. Potassium is 19. 20 is calcium. Argon is a noble gas. Also with this, you will be having neon. Neon is also noble gas. Okay, we will learn about this in the future chapters. This is periodic classification of elements. There we will have the 18th group elements. Which group elements? 18th group elements. So they are called as noble gases or inert gases. They won't react with other elements. That's the only thing. Okay. Next we will learn about this mass number. Mass number. This mass number is represented by A. Right? A represents mass number. Mass number till 20 atomic numbers, it's approximately double than the atomic number. Mass number is approximately double than the atomic number till 20, but we have some exceptions. As we know, in chemistry we have some exceptions. Sodium, which have atomic number 11, will have mass. Mass will be 23. Why means it's like that. You need to remember. You need to remember these exceptions. So you will be having again similar to that of sodium. You will be having potassium. Potassium is 19, but mass number is 39. It's not exactly double. 19 double is 38, but you will be having mass number as 39. These are the exceptions you need to mark. Okay, this is the thing. And this mass, I didn't tell you this definition of this mass number. The definition of this mass number is the total number of nucleons. The number of nucleons. The total number of nucleons in atom. See, the mass number A is nothing but the total number of nucleons in atom. I previously gave the visual representation of this atom. Suppose this is circular, and here it is atom. This nucleus. In this nucleus, you will be having neutrons and protons. Right? You will be having neutrons and protons. This number of neutrons plus number of protons. See, the number of neutrons plus number of protons is nothing but nucleons. We have the new name called as nucleons. Nucleons are nothing but the number of particles in this present in the nucleus. The proton and neutron, when they combine in number, they form nucleons. Total number of neutrons plus total number of protons in the nucleus of the atom form nucleons. The total number of nucleons in atom is nothing but mass number. You just note this down in a simple manner. I told you for a better example. Okay, next we will go to the representation. Element representation. Element representation. We go to this element representation. If the element is X, let us assume this as X, then the Z, as we know, Z is the atomic number and A is the mass number. So this is the general representation or element representation. If X is some element, any element, if X is some element, X subscript, this is called a subscript atomic number, and this A is called a superscript. Subscript Z and superscript A, this symbol is called as element representation. You will be, suppose first, so for example, I give you some carbon. Right? Carbon is a most important element in chemistry, as you know. In future we will be dealing with organic chemistry, where you will be learning about all this carbon, and also you will be seeing in inorganic chemistry, where you will be learning the P block. So this carbon, I'll write in the file, increase the font. C, let us this C, element C means carbon. What is atomic number of carbon? I just told you previously, right? It's 6. And what is the mass number? It will be 12. The one secret I want to share with you is the atomic mass is approximately, I don't tell you that it is 100% double than the atomic number, but in general, if we take till the elements of 20 atomic number, most of the elements have atomic mass will be double than the mass atomic number. Okay, so like this. Suppose I'll give you one thing. If you want the number of neutrons, if you want the number of neutrons which are present in the nucleus of an element, and if you know that atomic mass and atomic number of the same element, you can easily calculate this number of neutrons. This number of neutrons will be there. Number of neutrons formula is A minus Z. Just note down this formula, I'll write properly. Is A minus Z or Z, whatever you call. Number of neutrons is equals to A minus Z. A is atomic number, Z is A is the atomic mass, Z is the atomic number. So let us do one question. Now I am going to explain the number of neutrons present in the nucleus, that formula which I told you before. Number of neutrons in nucleus is given by the formula A minus Z. This A for atomic mass and Z is for atomic number. I previously told you that the atomic mass A is equals to the atomic number Z, which is nothing but the total number of protons. The total number of protons in nucleus. Atomic number is also, we can also define it as total number of protons in nucleus. So atomic mass is equals to atomic number, that is number of protons, plus number of neutrons. Let the number of neutrons be n. Let us call the number of neutrons as n. So according to this is a general thing. So according to that, we are deriving this formula. Okay, kindly note this down. Now I am going to tell you about. Okay, let us do some example. One good example, so that by applying this formula, you will be able to do more number of problems. This is the basic problem. We will do the JEE mains level and Neet level questions after completing this one shot, right? So if you take one example of element sodium, which is represented by Na, the atomic number of sodium is 11 and the mass is 23. It's a general representation which I told you previously. So this is nothing but the atomic number Z. Okay, I'll write big. This is Z. This is atomic mass A. So according to the formula, number of neutrons is equals to A minus Z. By substituting this, I am writing this step by step. As if this is the first problem. From next time you can calculate mentally. 23 minus 11, that is 12. There are 12 number of neutrons in the nucleus of sodium. So similarly, I will give you another example, that is carbon. I am going to tell you about the isotopes after this Rutherford experiment. Now you just consider this C614. This for actually C612, but since there are isotopes which I will tell you after 10 minutes, we are writing C614. This is one of the isotope of carbon. So according to the same formula, I am directly writing, since I already wrote here the steps. So the number of neutrons is equals to 14 minus 6. 14 minus 6, which is 8. There are 8 number of neutrons present in the carbon C614. Okay, kindly note this down. You take a screenshot, it will be better. Okay, this is the basic idea about this number of protons and number of electrons, atomic number and atomic mass. So now I am going to tell about the terms which are going to be used in the JEE, Neet, EAMCET and the board exams like CBSE and other state exams. They'll use some terms, you should be very careful. First one is isobars. This isobars, I'll tell you and then I'll write. Isobars are the atoms having same mass number but different atomic number. Isobars. These are atoms. Isobars are atoms of same atomic mass or same mass but different atomic number. Means the elements which you will be observing in examples will not be the same. They will be different, but they will have the same mass. An example for this is carbon C614, which I told you previously, right? In the previous example, to calculate the total number of neutrons. So C614 is one element we are considering, and another element is nitrogen. Atomic number of nitrogen is 7, which I told that from atomic number 1 to 20 elements. If you do not remember, please go through that. Nitrogen 7, 14. This will also have the same mass. Mass number is 14, same, but different elements. This atomic number is different. That is the thing we need to observe carefully. Okay, note this down. Next we are going to deal with isotopes. These isotopes are the elements having same atomic number but different mass number, which I told you previously. Isobars, it's opposite to this. Their atomic mass is same, atomic number is different, but here atomic number is same but atomic mass is different. You just read this definition and write, and you will understand better by seeing the example. Isotopes, the definition is atoms having same atomic number but different mass number. I'll write NO for shortcut of number. You kindly understand it. Isotopes are the atoms having the same atomic number but different mass numbers. Mass numbers which I write in XZA. This is mass number A. A is mass number. So as an example, we'll take this. Yeah, which I told you previously, that carbon. I told you that carbon has some isotope. I wrote C614. I used two times. Now you observe it. Carbon has 3 isotopes. C612. C6. The atomic number won't change. The C613 and C614. Out of these 3 isotopes of carbon, this C614 is radioactive. This is radioactive. About radioactivity, you will be learning in the chapter of periodic classification, and you will be observing some elements in F block elements. But we need not worry about the definition and what is radioactive. We don't anywhere they won't ask. So we just remember it as they are radioactive. That's it. So okay, along with this, you will be having one chapter. Currently, it's deleted for CBSE. Previously, before 2022, it was there, and also in some state level exams you will be observing. So, isotopes of hydrogen. Isotopes of hydrogen. The hydrogen is the element of atomic number 1. Z is equals to 1. Here also same thing. Atoms will have same atomic number but different mass number. That is H11 and H12, H13. This is normal hydrogen which you will be observing in periodic table. H12 is called as deuterium. H13 is called as tritium. I will write down. Deuterium. This is tritium. Out of similar to this carbon, hydrogen also has tritium as radioactive. This tritium is also radioactive. Okay, you just do this mind map. It's like a mind map, so it will be useful for you. If you have any doubts, you just comment me down. And if you have any doubts or no clarity about at some particular place, you can comment me down. No problem. Now just take a screenshot and note down this. Okay, if you want for more time, you can pause this video. Okay. Next, the third word, keyword, which you will be observing and which are mostly used, which are mostly asked in this JEE Mains, JEE Advanced, Neet exams is isotones. Isotones. First one is isobars. Second one is isotopes. This is isotones. NES tones, right? Isotones. Here, the elements, atoms will have the same number of neutrons. The number of neutrons, that is A minus Z, which I told you, that neutrons will be same. The atomic mass and atomic number will be different. The atomic number and atomic mass will be different, but you will be having the same number of neutrons. Here, the atoms will have same number of atoms will be having same number of neutrons. Atoms will be having the same number of neutrons. That formula is A minus Z if you want to calculate specifically. So number of the atoms will have the same number of neutrons but different atomic mass and also different different atomic number Z. I'm writing the shortcut, so you'll be familiar with these shortcuts and the symbols which you will use for atomic mass and atomic number. So, okay, let us take this example. In all the examples, I used the same common element, that is C614. So, by this you can understand the importance of the carbon. So, see this C614, this element, and oxygen having atomic mass, atomic number 8 and atomic mass 16. So, if you observe these both elements, you will be having the same number of neutrons, that is 14 minus 6, which is 8, and similarly 16 minus 8, according to this formula A minus Z, 14 minus 6 8 and 16 minus 8 will be 8. So, so the same number of neutrons are there here. Okay, same number of neutrons are there. So by this we can say that C614 and O816 are isotones. So you need not remember that these are the examples, from these only they will ask. No, you need not worry about these examples. You only remember this definition. That's it. You take a screenshot and note down this. Okay, next. Okay, this is enough for the keywords. Next I will be telling you this Rutherford alpha scattering experiment. Rutherford gold foil experiment, you can say. Gold foil experiment or alpha scattering experiment. Okay, this Rutherford gold foil experiment. In this Rutherford gold foil experiment, Rutherford tried to contradict that J.J. Thomson, and he took one lead box like this. Okay, lead box or radioactive box like this. In this, since all the you remember one thing, all the radioactive elements will release alpha rays, beta rays, gamma rays, which will be learning in radioactivity of modern physics, that is nuclear chapter. So we just need to understand the concept, but need not have questions and doubts in the mind. So just understand this, you will be able to do numericals. If you have any doubts in numericals, I am there here to explain you. Right? This is a radioactive substance. Inside this box there will be radioactive element. There inside it will be radioactive element. In this, from this radioactive element, alpha particles will be passed. Alpha particles. Okay. You may ask, what is an alpha particle? Okay, I will tell here, and after that I will know. Alpha particle. Alpha particle. Okay, I will tell you the basic definition of alpha particle. Alpha particle, which you will be hearing in 10th grade. There you will be asking some questions that calculate the mass of, tell the mass of alpha particle, positron, proton. These are interrelated words, but they have difference. They have so much difference in their meanings, original meanings. Alpha particle is nothing but the dihelium positive ion. Dihelium positive ion is alpha particle. That is, alpha particle is helium, dihelium. Di means 2. Dihelium positive ion. Okay, for your understanding, helium atomic number is 2 and mass is 4. This is called as alpha particle. Okay, you can write plus dihelium positive ion. This is the alpha particle. Okay, you note down this. I will draw the complete figure of this. Okay, particles. Okay, there the Rutherford placed one gold foil like this. You need not worry about this drawing. If you have any problem, for that I am just labeling this. If you want greater clarity, you see the pics in Google. it will be good clarity for you. This is gold foil, and surrounding this he placed one screen. Okay, okay, it's actually three-dimensional, but since this board is two-dimensional, I am able to draw like this. Okay, according to this Rutherford experiment, what he did is, these alpha particles are released from this box like this, and Rutherford observed that most of the alpha particles are passing this gold foil without any deflection or without any deviation. Most of the alpha particles, but I cannot exactly tell this percentage, and it varies in different books. In my material, in the NCERT, it differs, but there's no clarity about the percentage. But you can say most of the alpha particles will pass this gold foil without any deflection. Like if you consider my finger as an alpha particle, it will go like this, and it will hit the screen. This is nothing but the screen where you will be observing whether alpha particle heated here or not. Here actually some fluorescence material has been kept to glow, so I am marking this. Okay, that's this. Okay, most of the alpha particles pass this gold foil without any deviation, and some of the alpha particles deviated with small angles. If I consider this as horizontal, it made some angle theta. Let us say this particular alpha particle made angle theta. Again, here alpha, you will be confusing between two alphas. So this is theta, let us say. So most of the alpha particles passes gold foil without any deviation. Some of the alpha particles deflected with small angles, not big angles like from here to here. It is deflected from here to here. No, only with small angles. Instead of moving like this, it moved like this. That's it. No more deviation is observed. Some of the alpha particles are deviated like this, and one alpha particle in 10,000 alpha particles retraces its path with 180 degrees. Suppose here it's clumsy, so let us understand this deviation completely, deflection by this example, by this figure. This is gold foil, let us say. This is gold foil. Okay, very rare, 1 in 10,000. I'll write all these points, don't worry, you just understand this. If you understand, you can make your own points. So understanding is the key way to success, right? So if you pass like this, this is only one alpha particle in 10,000 alpha particles which we pass here. Okay, it will retrace its path and will move in 180 degrees. 180 degrees it will deflect and come back. This is very rare. He observed that this wherever this alpha particle is retracing its path with 180 degrees angle, there he observed that there is a nucleus. Since this alpha particle is positive ion, which I told you, like He24 plus itself says that it's a cation. This positive charge and this positive charge which is there in the nucleus, in gold foil there will be number of gold atoms. Inside that atoms you will be having nucleus which is very small. In that small part, if this alpha particle goes, and then this positive charge in helium ion, alpha particle, and this positive charge of nucleus will deflect, will move in opposite direction, since like charges are repel and unlike charges attract. So these are like charges, they will repel. So this is the thing, and this is the funda of this Rutherford gold foil experiment. Okay, we will write down the points, and you also have one formula. Sometimes he may ask in some 10 years, in some 10 questions from this chapter, structure of atom, you will be having at least one question based on this formula which I am going to tell you. You will just draw as per your convenience. I can understand that from the 10th grade, you will be having a big jump to the 11th grade like this. If till first to 10th class its graph is like this. From 10th to 11th it will be like this, I can understand. But from these examples you try to understand. You don't panic by seeing these diagrams. What is this theta? I don't know anything. This horizontal, what is he is telling? Vertical angle, horizontal. I'll explain. I explained. You don't confuse. Here theta is again assuming the angle. Since you learned in trigonometry in your class 10th, this theta indicates angle. So I took this theta as angle. That's it. Okay. I'll write down the points. The conclusions which are given to this Rutherford gold foil experiment. Most of the alpha particles passed gold foil without any deviation. Since I told you the first point, when I draw the figure, most of the alpha particles pass the gold foil without any deviation, and some of them deflected with small angles. So most of the alpha particles passed the gold foil without any deviation. Some of the alpha particles deflected with very small angles theta, which I told you previously. Okay. Next, one alpha particle. Okay, I'll write one alpha particle in 10,000. You don't remember the 10,000. Okay, it's approximately 10,000. Okay, one alpha particle in 10,000 passed deflected, I can say. 10,000 alpha particles. One alpha particle in 10,000 alpha particles deflected or retraced, we can say. Alpha particles retraced its path by 180 degrees. It's completely straight, opposite. If it moves like this, it reverses like this. Okay, you just note down this, and we will be writing the Rutherford what he gave about the atom. This is the experiment. About this experiment I just told you. Now I will be telling you the conclusions which he drawn from this experiment, alpha scattering experiment, a gold foil experiment. Just take down the screenshot. Okay. Now the conclusion. Now the conclusion you will be seeing is conclusion, or you can say the observation from what he observed in the atom from the Jeeadvanced model. What is the difference? You can understand by this exam, by this properties given by the Rutherford. Conclusion, you can say atom is spherical in shape. Atom is spherical in shape with its very small nucleus. Very small nucleus present in center of nucleus, present in center of atom. Okay, atom is spherical. He concluded that atom is spherical in shape, like your ball, with its very small nucleus present in center of atom. This, if you want the size of nucleus, and he also told that size of nucleus. This should remember in modern physics or in this chapter structure of atom. You will be seeing numericals based on this. You should remember this value. Sometimes he will mention that one nucleus is 1 Fermi, or in most of them he will not mention. So better you remember this. Size of nucleus. Size of nucleus is 1 Fermi. You may ask, what is 1 Fermi? 1 Fermi is nothing but if in CGS, in MKS unit, that is SI unit, 1 Fermi is nothing but 10 to the power of minus 15 meters. Always any quantity or any standard physical quantity you want to understand, you just need to mention in MKS unit or SI unit. MKS means MKS. It's a standard unit. It's a SI unit. If you give in centimeters or any other SEGS unit, FPS unit, or any other random unit, you need to mention by any problem solving. After solving the whole problem, you should mention in MKS unit. Otherwise, in board exams, the examiner may cut half mark or 1 mark unnecessarily. So better you remember. M means meter. Okay, K means kilogram, kg. Where you will buy rice in 25 kg. That is only kg, kilogram. The S is nothing but second. Time. This is a unit of time. Meter is a unit of length. Kilogram is a unit of mass. And second is a unit of time. Okay, you have to write down this. Somewhere like note point, you need to write note. N-O-T, note. After that, if you write like this, before exams, you can easily revise. Just write this. I'll Fermi, yeah. And size of atom. We also give size of atom as 1 angstrom. An angstrom. Angstrom is like A, and above A you need to write this O, like O. This angstrom. 1 angstrom is 10 raised to power, or 10 to the power of minus 10 meters. This is like, this is the whole atom, and this is the nucleus. It's very, very small. If I hold one ball in hand, from here, till 5 kilometers radius will be the atom radius, whereas the nucleus is very small, the radius of your ball. That's the example given by him. Okay, you just wrote it down. You will have some 2 conclusions. Now, he also told that electrons always move, or you can say revolve, it's a better word. Electrons always revolve around the nucleus in circular paths. He didn't say that these circular paths are orbits, but the orbits word or shell word, which is which we use in our regular life, that is given by Bohr, Niels Bohr. Okay. The electrons always revolve around the nucleus in circular paths. It's completely different from. So it's completely different from J.J. Thomson experiment. It's completely different from J.J. Thomson experiment. Note this down. Now, This is the conclusion. These are the conclusions given by Rutherford. Now we will be having formula, that is number of alpha particles deflected. Number of alpha particles deflected number of alpha particles deflected is equals to 1 by, in some books it's mentioned that proportional, but by removing that proportionality we can keep some constant k, and let us assume that constant as 1. So in most of the questions you will be asking about the equation but not the expression. That expression means where you will have the proportionality. If you have equal to, that is equation. So number of alpha particles deflected is equals to 1 by sine to the power of 4 theta by 2. This is power, 4 power, 1 by sine to the power of 4 theta by 2, where theta is nothing but the deflection, which I told you previously, right? If this is the gold foil and this is the horizontal, if the alpha particle is deflected like this, this is the angle theta. This theta angle itself is where we are using theta. So number of alpha particles deflected is equals to 1 by sine to the power of 4 theta by 2. Okay, I will give one question problem. You just note down this. Number of alpha particles deflected is equals to 1 by sine to the power of 4 theta by 2. You just remember, you need to read for yourself for 5 times. Then you will easily remember. Not only remembering, if you even remember for 10 times, you will not be remembering for 1 time. You need to revise 2-3 times. So you will be in sleep also you can tell the formula. Based on the formula, we will do one question. It's just a substitution question, that's it. If, example, if theta, that is the angle of deflection, is 30 degrees, if the angle of deflection is 30 degrees, then how many alpha particles deflected from their path, from their original path or path, whatever you can say. If theta is equals to 30 degrees, angle of deflection 30 degrees, how many alpha particles deflected from their path? The solution for this is, since from the formula we know that number of alpha particles deflected from their path is 1 by sine to the power of 4 theta by 2. Okay, we will take this 60. Otherwise, you will be confusing whether you don't know. I think you don't know the value of sine 15. You will be learning in mathematics, trigonometry. So, for your better understanding, let us take 60 degrees. If theta is equal to 60 degrees, then 1 by sine to the power of 4 theta by 2. So 1 by sine to the power of 4 theta is nothing but 60. So 60 by 2 is 30. 1 by sine to the power of 4, 30. The 60 by 2 is 30. 1 by sine to the power of 4, 30. 30 sine 30. What is sine 30? Sine 30 is 1 by 2. And right here, note sine 30 degrees is equals to 1 by 2. After this, I will be writing from sine 0 to sine 90 what are the values. So you better remember. I think you might have learned in 10th grade. Okay, let us recall. So since sine power 30 is equals to 1 by 2, then sine 30 is 1 by 2. So 1 by 2, 4 power 4. 1 by 1 by 2, it will reciprocal. So it will be 2 power 4, which is, if you want, you can split 2 square into 2 square. This 4 4s are 16. 2 power 4 is 16. So total number of alpha particles deflected if the angle is 60 degrees is 16. Okay. Just note down this. Okay, these are the conclusions which we made from the Rutherford gold-foil experiment. Next, we'll see. You need not write this failures of this Rutherford model, why it failed. It's just for your knowledge purpose. That's it. Mostly the question will not be lifted from this topic, which I am going to teach now. These are failures or drawbacks. You can say, you can write failures. Okay, we'll write drawbacks. It's a good word other than failure. He did a lot of work, so you should not tell him as failure. So drawbacks of this Rutherford gold-foil experiment is, first one is this Maxwell's classic theory. Maxwell's classic theory. You will be having one theory. We don't need to learn and remember this Maxwell's classic theory. According to this Maxwell's classic theory, what happened is, because of this Maxwell's classic theory, this Rutherford experiment has been failed. What happened is, he told that atom is like this and electrons are revolving in this path. Okay, he didn't tell that electrons are revolving like this, and he did not mention about orbits, anything. Okay, it's a rough diagram. Kindly don't mean anything, you just understand. According to this, what he did is, suppose this is one electron, and Rutherford told that if you go in depth, you will understand that this electron is an accelerated particle which will release energy, go on release energy. If it will do like that, if this is the nucleus and this is electron, according to this Maxwell's classic theory, what happens is, this electron will radiate energy and move in spiral path and crash the nucleus. If it crashes, then there is no world. If there is no world, it does not make any sense. So, according to this Maxwell's classic theory, the electron will move in the spiral path and crash the nucleus. So, in some 10 to the power of -8 seconds, okay, we will not go in depth. So, in this very less time, it will hit the nucleus, but it will not happen. So, this is the first drawback. And second one is, he couldn't explain stability of atom. So Rutherford failed to explain the stability of atom. He did not say why the electrons revolve in circular path only, not in any other path, and why the nucleus is at center. According to that, there is no stability. From this experiment, Maxwell's classic theory, there is no stability. So from the one point, you can remember these two. Okay, you just remember as two single points, but from based upon what I told you, you briefly can write. If it is for 2 marks, 4 marks, 8 marks also, you can easily write. If he asked in the worst case, right? So note this down. Take a screenshot. Okay, we are done with this Rutherford gold-foil experiment. Now we will move towards. Before learning this Bohr's theory, I need to tell you this about this spectra. No, not spectra. I will be telling about this Planck's theory. And before Planck's theory, I would like to tell you about this electromagnetic waves. Electromagnetic waves, how it will work. Most of the questions will be lifted from this. Electromagnetic waves, you can write as EM waves. Electromagnetic waves. If you will be learning the similar thing in oscillations chapter or waves chapter in physics, so it will be useful. If you learn here, it will be useful there. That's it. If this is the graph, these are the electromagnetic waves. Suppose, for example, let us consider this as electric wave I cannot draw this three-dimensionally, so let us take this. Don't confuse. It's perpendicular. If I tell, these are perpendicular like this, right? Like this. They will move like this, perpendicular to each other. Electric field. This electric wave, electromagnetic waves, EM waves, has two components. First one is, I'll try to find. These EM waves, electromagnetic waves, has two components. Two components. These electromagnetic waves has two components. First one is, from the name itself says that E for electric, M for magnetic. So these electromagnetic waves have two components. First one is electric component, or electric part you can say, but component is an apt word. Electric component. And second one is magnetic component. Magnetic component. Component is nothing but part. Component. Okay. These electromagnetic waves have two components: electric component, magnetic component. And these waves, these EM waves, travel or move with velocity. These move with velocity of light. In any medium, mostly you will be considering vacuum, where there is no air, no friction, no viscous forces, and all other opposing forces. You will be telling it as vacuum. Most of the experiments will be performed in vacuum itself. So these electromagnetic waves travel with the velocity of light. Okay, these electromagnetic waves travel with the velocity of light. The velocity of light is represented by the symbol C. C stands for velocity of light. What is the value of velocity of light? The velocity of light, C. Okay, you note it down. I'll write from top for better visibility. Okay, this is magnetic wave. This is the wave propagation. In physics, we will be telling this as S bar. That is wave propagation direction. S cap denotes direction. Unit vectors denote direction. So wave propagation. Okay, wave propagation. Okay. These electromagnetic waves travel with velocity of light. Okay, you note this down. Okay, I'll keep this diagram as it is. I'll not put this. Okay. The velocity of light C is equals to 3 into 10 to the power of 8. 3 into 10 power 8 of 8 meters per second. M by S. Meters per means by, divided by, division. So velocity of light C is equals to 3 into 10 raised to power 8 meters per second. This is the standard value. The same thing you will be using in, not only here, you will be using in mostly in physics, this photoelectric effect, dual nature of matter, at the nuclei, atomic, where you will be having atoms, and modern physics, this wave optics, not all. This value has is very important, that in wherever you go, it follows. That's it. So these electric component, electric component, magnetic component, this magnetic component, this electric component, magnetic component, and wave propagation. Wave movement, for better understanding, wave movement, this is in that direction. For better understanding, consider like this, all three fingers like this. Let us understand that if all these are mutually perpendicular, so if you take this as a magnetic field, this is electric field, and this is wave propagation. the direction of wave propagation. This is magnetic field, electric field, wave propagation. You can take any of them as different names, but I want to tell you that these are mutually perpendicular, means they are at 90 degrees. So they will run like that. The electric component, magnetic component, wave component movement are mutually perpendicular. Mutually perpendicular. This perpendicular, we will be using the symbol like this. Perpendicular. Okay, note this now. Okay, I'll write here itself. Some another point. Now, okay, I need to use the whole space for explaining you the next component in what will be there in this in waves. In waves, you will be having this crests, troughs, amplitude, some other words, new words you will be dealing with. So I'll explain using the one graph similar to this, but it's not that complicated, which I'm going to draw. Here, for simply you understand this is one wave. Why? Let us take some electric field wave, electric component like this. From this is y-axis, this is x-axis. I'm drawing roughly. Don't mind. The upper part which is there from here to here is called as crest. Okay, I'll label here crest. From here to here, the upper part from this origin, let us take 0, 0, since it is two dimensional, 0, 0. From here, the upper part, what will be there in positive y-axis plane, this is crest, called as crest. The upper part of this wave is called as crest, and the lower part below the origin is called as trough. T-R-O-U-G-H, trough, right? Trough. Now, from, okay, now I am not telling that from here to here. I mean, I told you correctly, but for your understanding, this crest is nothing but from here to here, what it is there. The graph, from here to here it is trough, here to here is crest. Upper part is crest, down part is trough. Okay. Now I am going to tell you about amplitude. In any part, if you consider these maximum parts, the maximum points are called as peak points, is called as amplitude. The maximum distance from its, in oscillations you will be having the maximum distance from the mean position is called as amplitude. Similarly, the maximum distance from its origin is called as amplitude. In this case, in anywhere you go, this amplitude means the maximum distance. You just remember amplitude, you just mind map like this. Amplitude means maximum distance. Amplitude means maximum distance. Okay, you can understand. I don't need to write by this. You can also just write it as a short notes. This is crest, this is trough, and this is amplitude. Now, wavelength. The most wanted question is wavelength, upon wavelength. The wavelength is represented by the symbol lambda. This lambda indicates this wavelength. Wavelength is nothing but the distance between the two waves. The distance between the two waves is called as wavelength. The name itself says wavelength. If you break this into two words, wavelength, the length of the wave, the length between the two waves is called as wavelength. You should only, this wavelength is nothing but, for proper definition, wavelength is the distance between, it is the distance between crest and crest or trough and trough. Okay, the wavelength lambda is nothing but the distance between the crest and crest or trough and trough. That's it, between the two troughs and between the two crests. If you take both, any of them or both of them will indicate the same value wavelength. You will be having the relation. You will be having the relation between wavelength lambda. Okay, you note on this. I'll write here. Relation between C, that is velocity of light, relation between C and lambda. Relation between C and lambda is C is equals to lambda nu. This is a very important formula which you will be observing in most of the numericals. It is relation between speed of light in vacuum and lambda is a wavelength. Whereas, see, I'll label it. I'll write the meaning of each of the letter which is represented here. Velocity of light in vacuum, whereas lambda is wavelength. Nu. This is the new word which you will be understanding in Planck's quantization theory, which I will be explaining next. You just need not worry about this nu. This nu means it's like V. V is like this. I'll write properly. Which I am writing it as nu. This V and this is nu. You like this. You need to write. This is nu. And this is nu. This is the difference. Most of the people will represent with V only, but if you want to label this V, that is velocity of light in medium, not vacuum, and nu, what you should label the same thing V. So it's not correct. So you should represent it with nu itself. Nu is nothing but frequency itself. See, in hertz. The frequency hertz represented by Hz. Okay, C is equals to lambda nu. You repeat this 5 times. C is equals to lambda nu. 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 You should tell with me, so you will be remembering. Okay, I didn't tell you this. Yeah, nu is the frequency in hertz. You will be listening this sound in frequency. Hertz. The unit of this frequency is hertz. You might have encountered this word frequency in your regular life. The frequency means it's represented by nu. The frequency has no proper definition, but by this relation you can understand. Frequency in hertz. The SI unit of frequency is hertz. This hertz is nothing but. Okay, you stay screenshot. I'll explain about the unit hertz and what it is actually. Okay. Understanding this electromagnetic waves is not that easy for a beginner. If you are learning this for the first time, then you need to study. After the class, you need to go through the notes and make your short notes. I am giving short notes by points which I made previously during my JEE preparation. So it will help you a lot. Okay. Nu, which I told you, has a unit of hertz. H-E-R-T-S. Hertz. It is represented by Hz. 1 Hz is equals to 1 second inverse. That is means 1 hertz is equals to 1 second. 1 hertz is equals to 1 second inverse. It's reciprocal. S is here reciprocal. So 1 by S is right. Simply Hertz is nothing but reciprocal of seconds. That's it. The hertz, it is related with time. So if you write the dimensional formula of hertz, the dimensional formula of hertz is T inverse. You'll be learning in some basic concepts of chemistry and units and dimensions. The same thing. So the time 1 by T means T inverse, you can write this. This is the dimensional formula. If you want more precisely, M naught LT. I was saying the dimensional formula of frequency. Frequency represented by nu has a dimensional formula. Okay, frequency is nothing but, as I told you, it's a reciprocal of time period. Frequency is nothing but it's a reciprocal of time period. That is nothing but 1 by T. So nu is nothing but 1 by T. And since we know that from this formula, C is equals to lambda nu, which I explained you, which is a very important formula. Now the dimensional formula, dimensional formula of frequency nu. The dimensional formula of frequency nu is M naught L naught T inverse. This is the dimensional formula of frequency. Now, okay, let us do one example based on the formula of C is equals to lambda nu. Always the frequency is mostly provided in angstroms or sometimes nanometers. So let us understand this. If wavelength of some electromagnetic wave is 2 nanometers. Okay, let us say 2 angstroms. It's better. Okay, if wavelength of some electromagnetic wave is 2 angstroms, then find the frequency, of that wave. This is the solution which I am writing now. According to this formula which I wrote, that is C is equals to lambda nu. Since we know that the C, value of C, that is speed of light, is 3 into 10 to the power of 8 meters per second. The speed of light is 3 into 10 raised to the power 8 of 10 to the power of 8 meters per second, which is a fixed value. From this we can calculate the frequency according to this equation. So from this nu is equals to, so lambda will go that side, C by lambda. So C means 3 into 10 raised to the power 8 by the wavelength. The wavelength is given as 2 angstroms, and we know that 1 angstrom is 10 to the power of minus 10 meters. This is in SI unit. We should always express in SI unit. So nu is equals to, I wrote here. So 1 angstrom is 10 to the power of minus 10 meters. So 2 angstroms means 2 into 10 to the power of minus 10 meters. So according to this, 3 by 2 into, if minus 10 power goes up, it will become 10 to the power of 8 plus, minus will become plus 10. Okay, 3 by 2 is nothing but 1.5. 1.5 into 10 to the power of 18. Okay, I'll write nicely. 1.5 into 10 to the power of 18. 18 hertz. Hz. 1 into 10 to the power of 18 Hertz. This is the solution for this small example. If you understand this, we can go for Planck's theory of quantization, where you will be using the formula frequently. So please write this. Okay. Please note down and take a screenshot of this. Okay. Done. Okay, now we understood the basics with a good clarity. Now we'll move with a good clarity and complete our chapter as soon as possible and do the numericals based on this chapter. Now, okay, before telling the Planck's quantization theory, let me tell you the formula of c, that is speed of light, which will be used mostly in modern physics and also the structure of atom. The indirect questions may come. So the formula of the speed of light in vacuum is c is equals to 1 by under root mu naught epsilon naught. Okay, the formula of c, that is speed speed of light is formula of speed of light in vacuum is given by this formula. Given by this small formula, that is c is equals to 1 by under root mu naught epsilon naught. Just repeat it. C is equals to 1 by under root mu naught epsilon naught, and this mu naught is called as permeability of free space. Permeability of free space. Okay, mu naught is permeability of free space, and epsilon naught is permittivity of in free space. Permittivity. The name will be similar but not same. It will be somewhat different here. So epsilon naught is nothing but permittivity of free space or in free space, whatever you call. Okay. The value of this epsilon naught is actually, you don't need now at this stage, okay, but in most of the questions they'll mention, but let us note this for future use if there is any question. So mu naught is nothing but okay, you will be getting the answer of mu naught by 4 pi. Mu naught by 4 pi is 4 into 10 to the power of minus 7. Okay, this is the value. Okay, at this initial stage you don't need the value of mu naught, but sometimes epsilon naught is very useful. So epsilon naught is 8.85 into 10 to the power of minus 12 SI units. Okay, you don't need the units. The units will be very big and you will not understand until you come to the 12th class, that is electric charges and fields, where you will be learning that the force F is equals to 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is the formula from where you will be deriving the dimensional formula of epsilon naught, and the unit also you can remember from this, but we don't need at this stage, I guess, right? We will note this, and it's not that important. Not much important. You cannot say that it's completely deleted or it will not be asked. It's not like that. But just note it down and understand. Okay, you need not revise every time you read. However, you will be learning in electromagnetic waves of physics chapter and in other chapters also. Okay, right. Next, we'll go to Planck's theory. Planck's theory of quantization. Planck's theory of Quantization. Now you will be learning about this Planck's theory of quantization. You may tell, brother, what is Planck's theory of quantization? Okay, you may ask this, what is Planck's theory of quantization? Planck's theory of quantization states that suppose there is one body. According to this, Planck, who is a scientist who gave that, suppose this is a black body. Okay, black body means it's not as per looks, we can say it is black body. He named a body as black body which emitted and absorbs all the frequencies at any temperature. This is the conclusion given by the Planck. Okay, let us first understand what is a black body. Black body, it is a body which emits and absorbs, all frequencies. Black body, it is a body which emits, means it releases. Black body is a body which emits, that is releases, and absorbs all frequencies at any temperature. At any temperature is called a black body. Okay, let us draw a diagram for this. Suppose this is one black body. Okay, some random body. Let us take for example. Okay, I'll draw this properly. Let us consider this rectangle as some black body like this. If this is a black body, this will emit, means release, and absorbs all types of frequencies at any temperature. This is called as black body. Okay, did you understand the point? This is the key point you need to do, remember, understand. So black body is a body which emits and absorbs all the frequencies at any temperature, is named as a black body. You understand this definition? That's more than enough. Okay. Now, what is a Planck theory? According to the Planck theory, what he told is energy cannot be emitted or absorbed. Okay, energy cannot be emitted or absorbed continuously. Okay, the energy cannot be emitted or absorbed continuously by black body, which I told you previously. Body. Okay, you just listen to this definition completely and write down. Okay, energy cannot be emitted or absorbed continuously by a black body. Energy cannot be emitted or absorbed continuously by a black body, but can be done in small packets called as, okay, instead of writing called as black body, but energy cannot be emitted or absorbed continuously by a black body, but can be done in small packets known as quanta. Okay. According to this theory, Planck's quantization theory, this is the key concept. That is, which I told you, black body previously. Let us consider this as black body. If this is a black body, this cannot emit. That is, this cannot release the radiation, or this cannot release the radiation or absorb the radiation continuously. Means this black body cannot release or absorb radiation continuously, but can be done in small packets. Means it can, in break it will release energy or absorb energy. This it will release or absorb in small packets called as quanta. And according to him, he found one proportionality between energy E. Energy is symbolized with the letter capital E. So energy is directly proportional to the frequency. Frequency, which I told you, nu, represented by nu, which I told you previously. Energy absorbed or radiated by a black body is directly proportional to the frequency of the radiation supplied. We don't want the definition from. Always you remember one thing, that in any of the concepts, if there is a proportionality or any equation, from the equation itself you can write the definition of it as per your understanding. So E means energy, nu means frequency of the radiation. So which energy we are talking about? The black body radiation, right? This E means black body radiation or energy. Energy cannot be emitted or absorbed continuously, but can be emitted or absorbed in small packets known as quanta. So energy is directly proportional to the frequency absorbed or radiated. This is the conclusion given by the Planck, scientist Planck. So E is directly proportional to nu, and by removing this proportionality we get E is equals to h nu. This is the very important formula. This is a very important formula. That is, if E is directly proportional to frequency nu, then E is equals to h nu. Now what is the formula? Without seeing you tell me. E is directly proportional to nu is the expression, and E is equals to h nu is the formula. What is the formula? E is equals to h nu. E is equals to h nu, where h is known as Planck's constant. What constant? Planck's constant. Okay, in this equation E is equals to h nu, h is known as Planck's constant. This Planck's constant has a fixed value. You need to remember this value, because most of the students will confuse and make a mistake in options of, if suppose if there are 4 options, if you confuse in the power of the 10, then you may commit a mistake there. So you must remember the formula of, the value of h, that is h is equals to 6.626 into 10 to the power of minus 34 joule seconds. Okay. What's the value? What's the value of Planck's constant? The value of Planck's constant is h is equals to 6.626 into 10 to the power of minus 34 joule seconds. H is equals to 6.626 into 10 to the power of minus 34 joule seconds. This is the value of the Planck's constant. You need to do, remember, understand. Okay, very important. So in some questions, not in some questions, I can say in 50% of the questions you will be noticing the value of h, but in other questions you will not be provided with the value of h, unless it is an integer question. In integer question they will mention that sometimes you should only take till 6.6, sometimes people will take 6.63, but you need to remember this exact value to get the precise value in to mark the precise option in your exam. Okay. Joule seconds is the unit of h. What is the unit of h? Unit of Planck's constant h is joules seconds. Joule seconds. Okay. Take a screenshot. I'll give you some 5 seconds. Okay. I hope you've written this. I'll give you one question based on this. Okay, before giving one question, I would also like to tell you that if there are n photons, if there are n photons, then Planck's theory, Planck's formula is just, previously you used to write E is equals to h nu, right? Instead of before h you place one n. This is nothing but n. N stands for number of photons. This you need not remember. You just calculate for E is equals to h nu. Instead of after doing h nu, you just multiply with the number n which is provided in the question. Without mentioning the value of n, you need not use this formula. Otherwise, you use E is equals to h nu. unless it is mentioned. Okay, you will do one question. Okay, I will do one simple question. Second question, I will twist the question. That is some board level MCQ or state entrance exam, which you will get the questions like that. Suppose if, okay, I am writing the question in shortcut to reduce the time of the video. So if E is equals to some 30 joules, and okay, if E is equals to 30 joules, calculate new value. Okay, what is the value of frequency? Don't think about this formula, because we are only dealing with one photon. So n means they are one only, so no need of writing n. So solution is E is equals to h nu is the formula. So according to this equation, if h goes this side, E nu is equals to E by h. Okay, this is the formula. E is equals to h nu, nu is equals to E by h. According to this, which means nu is equals to 30 by, since we know the value of h, that is 6.626 into 10 to the power of minus 34 joule seconds. This is also in joules. This is also in joule seconds. Right? This joule and joule will get cancelled. Okay, this joule and joule get cancelled, and the unit of this is per second, which is nothing but hertz. The unit of this will be hertz itself. So nothing to worry here. So upon calculation you will get 30 by 6.6. Okay, we will do here 30 by, this is rough work, let us keep, okay, 30 by 6.626. okay, 30 into 1 2 3 by 6626. This is the thing. By cancelling the two table, 2 3s are 6, 2 3s are 6, 2 1s are 2, 2 3s are 6, and 2 15s are. Okay, approximately you can write this as 15 into 1000 is 15,000 divided by 3313. Okay, if you do division, okay, I will do this for your better understanding, and next question I will just give you the question, and after some 10 seconds I will give you the solution. So you just pause the video and solve the question. Okay, I will solve here. So it's a big division, it looks like that, but it's so common when you prepare for JEE or some state level exams. You need to do the calculation so fast. So for your understanding, I am doing some slowly. So 3313 across 3 5s are 15. So it's like 3.5. 3.3 is there. 3.5. So let us multiply with 4. 4 3s are 12. 1 carry. 4 1 4 plus 1 5. 4 3s are 12. 1 carry. 4 3s are 12 plus 1 13. Okay. It's 4. It's you can divide this with 4. So you will get this. You found dividing with. Okay. I'm rubbing the calculation here. You can do, I guess. So here I am doing this division. Okay, 10 minus 2 8, 9 minus 5 4, 9 minus 2 7. Here again you are taking borrows of 4, 4 minus 3 1, 1700. So writing point here you need to write 0. I hope you know the basic calculation. So after that, if you add 3 3 1 3 here, I think 3 2 plus 3 5, 6 2 plus 3 5, 3 plus 3 6. Okay, it's you can multiply this with this 5. So approximate answer you will be getting. Okay, 4.5. Okay, 4.5 into this 10 to the power of minus 34 will come upward and will become 10 to the power of minus 34 will become 10 to the power of plus 34. Okay, it's looking big. It's beginning with some another number, right? So I'll write small. You just zoom it if you don't have some clarity. It's hertz. Okay. This is the solution of the given question which I have provided. Take a screenshot of it. I'll give one example. You try to solve. I'll just give you the logic, calculation part you do. So we can reduce the time of this video. Not only time, it's also like homework. Okay, I'll just tell you the procedure. You comment me down the solution. Okay, take a screenshot. Okay. Another example. These examples are very important for solving this, at least some board level questions. After that, you yourself should practice and take yourselves to advanced level also. It only depends on you. If you have any doubt, I am free to explain you. If you have any doubt, you comment me down. Okay, I will give you my email also, so that if you have any doubt, you can send me the email. Okay, we will see that afterwards. Let us complete this chapter. Example: if wavelength is okay, let us take 3 angstroms. If the wavelength is 3 angstroms, this is first only I am telling this question is some easy to moderate. I cannot say if you are a beginner watching the video for first time, you may feel I cannot say that easy to medium. This will be some moderate to medium level question. If wavelength is 3 angstroms and energy of wave is some 10 joules, calculate frequency. Okay, it's a simple calculation. You just comment me down. You just comment the solution. Comment me down the solution of this question. I can solve it, but if you want a better practice and interactive class, you comment me down. So I can also understand that you are understanding my class to a better extent. You just write down the given information in shortcut. So wavelength is nothing but wavelength is 3 angstroms. 3 angstroms. Energy is 10 joules. Okay. One logic I'll give. What is the formula? E is equals to h nu. And we know that C is equals to lambda nu. According to this formula, right? We already know this formula. So nu is nothing but C by lambda. You can directly substitute the value of nu is equals to C by lambda here. So E is equals to okay, just a minute. Okay, instead of mentioning the wavelength, okay, we shouldn't mention the wavelength. If energy, yeah, okay, no need to write this wavelength. Otherwise, the question will be very simple. No need to write this. So if E is equals to 10 joules, and we know that nu is equals to C by lambda, you can easily calculate. Okay, I'll write them on the question. Wait. It will be very easy. Just wait. Okay, calculate energy if wavelength lambda is 3 angstroms or 4 angstroms. 4 angstroms. This is the case. The clue, I am just giving the clue. You can comment me down the solution. Clue is, do you know the formula? E is equals to h nu. And also you know C is equals to lambda nu. According to this, nu is equals to C by lambda, right? E is equals to h, instead of nu you can write hc by lambda. So E is equals to, after solving this, 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8 is the value of C, and lambda is given as 4 angstroms, is 4 into 10 to the power of minus 10 meters. After solving this, you will be getting the solution. So just tell me the solution, comment me down. If you have any problem, just ask me the question. Take a screenshot. This is a just clue. I am not giving the exact solution. Okay, take a screenshot. We completed this Planck's theory of quantization. Let us enter into the real world of chemistry, that is Bohr's theory. Bohr's theory. Bohr's quantum model. This is a better word to use model other than his rules. Bohr's quantum model. Okay, Bohr's quantum model. The first diagram which I drawn previously, this is the correct example of the Bohr's quantum model, and I personally imagine the atom as Bohr's quantum model, but because it's very easy to imagine. These are electrons. You suppose if these are electrons, they will revolve like this. Okay, in any direction, we don't matter. We don't have any relation with it. This is the nucleus. This is the atom. This is the atom. Okay. First rule which Bohr gave is electrons revolve in circular path around the nucleus, which is its center. Okay, electrons revolve in circular paths around the nucleus, which is at center. Okay, electrons revolve around the nucleus, which is at center. These circular paths are called orbits or energy levels or shells. Okay, you just understand this. Next, second theory, second point is that second point is, you just note down this. Okay, second point is, let us understand this. Second point is here. You just don't note down this. You don't have any. If you don't have any clarity, comment me down. You just understand this. Electrons revolve in circular paths around nucleus at center. These circular paths are called as orbits or energy shells or energy levels or shells. Okay. Electrons can only revolve in that orbits. Electrons can only revolve in those orbits whose angular momentum is represented by L, whose angular momentum is an integral multiple of h by 2 pi. Okay, electrons can only revolve in those orbits whose orbital angular momentum is an integral multiple of h by 2 pi. Okay, electrons can only revolve in those orbits whose orbital angular momentum is an integral multiple of h by 2 pi. So mathematically you can write MVR, that is angular momentum is given by the formula MVR. you will be learning in rotation chapter. MVR is equals to NH by 2 pi. This is the conclusion given by the board. MVR is equals to NH by 2 pi. What is the formula? Electrons can only revolve in those orbits. Electrons can only revolve in those orbits whose angular momentum MVR is an integral multiple of h by 2 pi. MVR is equals to NH by 2 pi. MVR is nothing but, MVR stands for angular momentum. Angular momentum. And h by 2 pi is a constant. N is nothing but is a constant. N is nothing but integer. Okay. N is nothing but the integer. This is the formula. And third point I will be explaining here. That is, third one is, when electron jumps from one orbit to another orbit, it will absorb or radiate energy. Right? Suppose this is some first orbit, this is second orbit, this is third orbit. Okay. If electron wants to jump from first orbit to second orbit like this, then it needs to absorb energy. It's like us only. Okay. If we eat something, then we can work happily, right? Without any disturbance, we'll be becoming more active. Similarly, electron also do like that. Suppose electron is in first orbit. For example, electron is in first orbit. It will absorb the energy and jump into the next higher orbits. One higher orbits are nothing but, after that, how much it moves up is called as moving up is nothing but jumping into higher orbits. Okay, if the electron jumps from first orbit to second orbit, it needs to absorb energy, then move to the second orbit. You just example, right? We take food and become active. Similarly, electron will take energy, absorb energy, and move into higher orbits. From second, if it absorbs energy, again it will go to third, fourth, fifth, and so on. After moving to higher orbits, if it won't absorb energy, there it will release energy and again come back in the same path and release energy. Okay, this releasing of energy is known as degeneration. Okay, degeneration. I'll write the point. First, you write the postulates of Bohr theory. Energy difference between shells. Energy difference between shells is given by, energy difference between shells is given by delta E, represented by delta E, that is change in energy. If electron, as I told you, electron either absorbs energy to move into higher orbits or radiates energy, releases energy to come down to the come back down to the lower orbits. Suppose if it want to go from first to second, it will absorb energy. If it want to come back from second to ground state, that is first shell, then it will release energy and then come back. Right? This is the story goes behind the electron. Okay. This delta E, that is change in energy, is the energy where electron absorbs or releases, which happens here. So delta E is nothing but, say, from Planck's quantum theory, what Planck's quantization theory, what is the conclusion? E is equals to h nu. Right? Similarly, change in energy delta E is also equals to h nu. This delta E is nothing but, delta E is equals to E2 minus E1. What is E2 and E1? The energy of these orbits. Suppose if electron jumps from second orbit to first orbit, if it jumps back to the lower orbit, it will release energy. Okay, the energy, let energy of first orbit is E1 and second is E2. Okay, if the energy of the first orbit is E1 and the energy of second orbit is E2, always higher orbits will have higher energy. That's the rule. So the energy difference is nothing but E2 minus E1. The energy of the higher orbit minus energy of the lower orbit, you will be getting the energy difference. So similarly, delta E is equals to E2 minus E1 is equals to h nu. This is the formula. This is the mostly asked, frequently asked questions in JEE Mains and Neet and other competitive exams. FAQs, FAQs means frequently asked questions. Okay, you just note down this. Okay, just note down this. Take a screenshot. Okay, I'll drop this. I'll explain the degeneration. What is the funda going behind it. The board is clean and green now. Okay. Now it's no need to learn about the terms, actual terms, and nowhere they will ask the definitions of jumping into higher orbits, jumping into lower orbits. You can directly write if electron absorbs energy, it will jump to higher orbit. If electron jumps from, if it releases energy, it will come back. I'll write the point. You don't need to remember the keywords which are unnecessary. We only want to focus on the points which are very important and necessary. And I am also covering the points which you need to understand for other chapters. It's linked to other chapters. Okay, after I studied properly, I am explaining. Okay, no need to worry. Electrons jump from lower orbit to higher orbit. By absorbing energy. Okay, electrons jump. It's P. Electrons jump from lower orbit to higher orbit by absorbing energy. Did you understand? Electrons jump from lower orbit to higher orbit by absorbing energy. Okay, I will draw the atom again. Please excuse with the diagram. Okay, this is the atom, right? And these are the shells. It's just imaginary. In real case, there will be no lines like that. We are imagining. That's it. Suppose this is one. These are some electrons. If electron wants to jump from here to here, suppose this is first orbit and this is second orbit. So these are nothing but these lines which I drawn. These are nothing but orbits. Okay, if the electron jumps from, if your electron wants to jump from first to second or second to third, whatever, from lower orbit to higher orbit, if electron wants to jump from lower orbit to higher orbit, if electron wants to jump from lower orbit to higher orbit, it will absorb the energy. Whereas if electron wants to jump from higher orbit, like if electron wants to jump from third orbit to second orbit, it needs to radiate energy or release energy. So the point I am writing is electrons jump from lower orbits. The electron jumps from lower orbits to, the electron jumps from higher orbits. Electrons jump from higher orbits. Electrons jump from higher orbits to lower by releasing energy of proper frequency. Okay. This is the postulate given by the board. I already explained you the three postulates. This is the meaning of the third postulate, which he didn't mention that clearly. So if you see the postulates, you will be only having 3. But this is the conclusion which I studied and gave you. Okay. He only gave that the delta E is equals to E2 minus E1 is equals to h nu. By seeing this, you will understand nothing. But after explaining that electron absorbs energy, it will jump from lower to higher orbits. Whereas if electron wants to jump to lower orbits, it will release energy. Okay, this releasing and absorbing energy, you will be having the next concept called as line spectra. Just take a screenshot of this. This comes under Bohr's theory, but it is given in book as a separate concept. Okay, let us learn as per book. Okay. Line spectra. Okay. Previously, I told you that electrons absorb energy and jump from lower to higher, and they release energy by jumping from higher to lower. Okay. When electron jumps from this higher orbit to lower orbit, it will release some energy. Okay, and instead of telling energy, it's better to tell radiation. When this radiation is passed through the spectrum, some instrument will be there. If you pass, you will be getting the band of colors. Means it is proved that the energy, there is some energy behind this. Bohr used this spectra to prove that electrons jump and release energy and absorb to jump into higher orbits. Mostly these color bands are mostly not used, but approximately it's VIBGR. VIBGR, as you know, as you are learning from your childhood, violet, indigo, blue, green, yellow, orange, red. VIBGR. It's a shortcut. But if it will not, if some of the energy radiation is absorbed, then sometimes you will not observe all the colors. Okay. But we don't want this concept. We only focus on the formulas and the logic going behind it. Okay. Okay. This you will have some Rydberg equation. Rydberg equation. Rydberg equation states that nu bar. This is the new word you will be learning. Nu bar is nothing but, it's not, nu means frequency. Nu bar means wave number. This number means wave number. What is wave number? Wave number is simply the reciprocal of wavelength. Wave number is simply reciprocal of wavelength. So nu bar is equals to 1 by lambda is equals to RH into 1 by n1 square minus 1 by n2 square. This is the very important formula. You need to understand. Okay. Rydberg equation is nu bar. Wave number nu bar is equals to 1 by lambda is equals to RH into 1 by n1 square minus 1 by n2 square. You may ask, what is RH? This RH is called as, the name itself says, Rydberg constant. Rydberg constant. Okay. And now what is the value of this? You need to remember this. Rydberg constant RH is equals to, I remembered it in centimeters, CGS unit, for better understanding. You can easily convert from centimeters to meter, meters to millimeter as per your wish, as per the question asked. RH is equals to 109677. It's I remember it like a phone number, so you can also remember like that. RH is equals to 109677. This is per centimeter. Is the unit of this RH. And okay, it's looking not good. Okay, no, it's good. RH is equals to 109677. 1,09,677. Okay, and N1 and N2 are orbit numbers. Orbit numbers from where to where the electron is jumping. Okay. This is the important thing. Wave number is reciprocal of wavelength. Okay, I will give you one question. Just note down this. Okay, N1 and N2 are orbit numbers. Okay, I'll give you an example. Okay, I hope you written this. Okay, if electron jumps from 5th to 3rd orbit, calculate wave number in terms of RH. Means instead of doing the calculation, if I start doing the calculation, it will take more time than 5-6 minutes. I hope you can do this calculation very easily. It's a simple calculation. But instead of wasting the time, I want to only focus on the concept other than calculation. I already shown you the calculation previously in some questions. It's not that difficult. You just remember that. Okay. What here is asked, if the electron, you just imagine the diagram of atom, which I gave in the Bohr's quantum theory, or that in the postulates I drawn one diagram, right? You understand that if electron jumps from 5th orbit to 3rd orbit, 5th to 3rd orbit means it will release energy, right? As per my points, you can understand it. If electron jumps from higher to lower, 5th means higher, 3rd means lower. If electron jumps from higher to lower, it will release the energy. Calculate wave number in terms of RH. So, according to the formula, nu bar is equals to 1 by lambda is equals to RH into 1 by n1 square minus 1 by n2 square is the formula. Okay, but upon substituting the values, nu bar is equals to RH into 1 by, always you remember one thing, this mu bar wave number is always a positive number. Always a positive number. Okay, this wave number nu bar, okay, it's looking like V. Always the wave number nu bar is a positive number. So it should not be negative. You need not number that what is n1 value, what is n2 value. If you get minus, you just consider that, you just write down the point. After solving, if you get some negative value, after solving some 3-4 minutes in board exam, if you are getting some negative value, you just write down the point as note, and the value of wave number cannot be negative, and can only be positive. If you write that 1 point, you will get the full marks. Instead of remembering this 1 by, always you remember 1 by some big value, 1 by some small value. Which is greater? 1 by 2 or 1 by 4? 1 by 2 is greater, right? So 1 by some small value is greater than 1 by some big value. Like example, 1 by 2 and 1 by 10. Which is greater? 1 by 2 is greater. Okay. So always the smaller the value should come here. So which should be smaller? The 3 square is 9. 9 will be smaller. Minus 1 by 5 square is 25. Upon solving this, you will get. Okay, for simple calculation, I'll give you the 4. Give you here the 4th orbit. So 4 square 16. 16. There's no. If you take the HCF, 16 2 8s are 2 4s are 2 2s are 2 1s are. You will not be getting any common value. 3 3s are 9. 3 1s are 3. So you just multiply with these both, take LCM. 16 9s are 144 by 9 is 16. 144 by 16 is 9. The value into RH is there here. 16 minus 9 is 7. Okay, 7 by 144 RH. This is the value of nu bar. That is wave number. If you want in terms of wavelength, the wavelength will be reciprocal of this. So 144 by 7 RH. This is the wavelength. Wavelength is always in meter, expressed in meter. You can save it. Just note down this. Okay, take a screenshot. These are very important points. Some people will confuse in exam. They will waste. Say, suppose the question solving time is 2 minutes, and they will be thinking that 1 by some big value or 1 by small value, which is bigger. So always remember, reciprocal of small will be big, reciprocal of big will be small. That's it. You just remember this. I personally used to confuse previously, but after entering 11th, I understood by solving number of numericals. And this is all you need to remember, that wave number is always a integer, positive integer. Z plus means positive integer. Okay. It may also be 0, but in most of the cases we won't encounter the value of 0. In this, I want to make one note point here. In this Rydberg equation, you will also have, this is only valid for hydrogen. This all Bohr's theory. This is one note point I forgot to tell you previously. Note, Bohr's theory is only valid for hydrogen and hydrogen-like species. Hydrogen-like species, like hydrogen, means hydrogen-like species means it should only have 1 electron, not more than that. Like hydrogen, helium plus, we have 2 minus 1, 1 electron, Li 2 plus, and beryllium, hydrogen, helium, lithium, beryllium 3 plus. These are the hydrogen-like atoms, okay, which have only 1 electron. This is the thing you need to note. In your box, you just make box neatly with a scale or mark with some glitters. Okay. This equation which I am writing now is valid for hydrogen and hydrogen-like species. For hydrogen-like the equation which I wrote to you previously, that is mu bar is equals to RH into 1 by n1 square minus 1 by n2 square. That is for hydrogen. Now I am going to write the formula of these hydrogen-like species for that Rydberg equation is mu bar is equals to 1 by lambda is equals to RH into 1 by n1 square minus 1 by n2 square into Z square. What is Z? Previously I told you. What is Z? Z is nothing but the atomic number. Suppose example, if you take Li2 plus, its atomic number is what? Atomic number is 3. For Z square, what will be the value? 3 square is 9. You directly substitute here and get the value. That's it. The example will be similar to this. Previously I told you the example. Instead of after solving the whole thing, you just multiply with Z square, that is atomic number whole square. Okay, I'll write the electromagnetic spectrum. According to the in ascending order, I will be writing the increasing wavelength. Electromagnetic spectrum, EM spectrum. Electromagnetic spectrum. The least wavelength, I will be writing in ascending order from smallest to highest wavelengths. There is increasing wavelength. Okay. This first one is cosmic rays. Okay. Next, I will be writing like this. It's increasing wavelength. As you go from here to here, it will increase. Cosmic rays, gamma rays, cosmic rays, gamma rays, X-rays, UV light, UV radiation or UV light, visible rays, infrared waves, microwaves, and finally radio waves. This is the electromagnetic spectrum. You may think why I am writing from here to here. You can easily understand. As we go, the wavelength will increase continuously. Okay, increasing wavelength. First is cosmic rays, which has least wavelength. Cosmic rays, gamma rays, X-rays, UV light, visible rays, infrared rays, microwaves, and radio waves. Radio waves, the wavelength will be very high. That some radio waves have 1 to 2 meters of wavelength. Like this, it will be very big. Whereas cosmic rays will be like this, very small. We cannot even draw this. Okay. Just note on this. Visible rays is the rays where we are seeing the things. We are observing this object. Suppose we are observing this duster. We are observing that here this is black color, this is some skin brown color. This is due to visible light. Some rays, like if you operate TV remotes, you will not be seeing the rays, the waves which are going. So we will be only seeing the very small part of your electromagnetic spectrum, which is visible rays. Okay. You need to remember this. I will make one video short to remember the wavelength of this. Okay. Note on this. We will continue this. Friends, now I am going to tell you about this series, Lyman, Balmer, Paschen, bracket, P-fund. Means when the electron jumps from one orbit to another orbit, which I told you previously, the electron will absorb and release the energy. When the electron jumps from higher orbits to the lower orbits, the different names are given by the scientists. So, I will make a table for your better understanding. I draw a table like this. Okay. Now, this is the series, name of that series, the name of the series, and this is N1, that is from where the electron is jumping. N2 stands for the orbit in which the electron is coming back. Okay, and this is region. This is the region. It means it differs in which region, which type of series is there. I'll write here serial number also. Here the serial number 1, that is Lyman. Lyman means if the electron jumps from the orbits like 2, 3, 4 and so on into the orbit, first orbit, then this transition is called as Lyman series. When electron jumps from any higher orbit other than 1, means from 2nd, 3rd, 4th, 5th, 6th and so on orbits, if the electron jumps from these higher orbits to the lower orbit, that is ground state, that is first orbit, then this transition where the electron is transiting is called as Lyman series, and this Lyman series lies in UV region, that is ultraviolet region. UV region. The Lyman series lies in UV region. Similarly, when electron jumps from any higher orbit, that is 3, 4, 5, 6 and so on, into the second orbit, orbit 2 is called as Balmer series. Okay. If any electron jumps from any higher orbit other than 2, that is higher orbit, that is 3, 4, 5, 6 and so on, into the second orbit, this transition is named as Balmer series. L is silent, it's not Balmer, it's Balmer. This Balmer is in visible region. Visible region. Visible region means we can see. So this transition Balmer series is visible. It lies in visible region. Next, third one is Paschen. Paschen. When electron jumps from any higher orbit into the third orbit, then that series is named as Paschen series. When electron jumps from any higher orbit into the third orbit, then that transition is called as Paschen series. The higher orbits will be other than the higher orbits for 3 are 4, 5, 6, 7 and so on. Okay, this Paschen lies in near IR region, means near IR stands for infrared region, means in these series you will be seeing near IR, middle IR and far IR, far infrared rays. Means in this series you will be observing these 3 infrared regions, that is near IR, middle IR and far IR, far infrared region. Now similarly, fine, okay, this is enough. Here fourth one will be bracket, B-R-A-C-K-E-T-T, bracket. The fourth one in the series we have is bracket. When electron jumps from any higher orbit, you just imagine orbits means the atom and in the atom nucleus and surrounding it you will be having the orbits. These orbits, when in bracket region, means the transition in which when electron jumps from any higher orbit other than 4 into the fourth orbit is called as bracket series. When electron jumps from any higher orbit to the fourth orbit, it is called as, the transition is named as bracket series. 5, 6, 7 and so on. This lies in middle IR, middle infrared region. IR stands for infrared region, and UV stands for ultraviolet region. Whereas Lyman, Balmer, Paschen, bracket, P-fund. It's not P-fund. You should spell it as fund. F-U-N-D, P-F-U-N-D, fund. Most of the people will spell it as P-fund, but as per the correct spelling, as per the correct English, you should read it as fund. When electron jumps from any higher orbit to the fifth orbit, similarly, when electron jumps from any higher orbit to the fifth orbit, like from 6th, 7th, 8th and 9th orbit and so on, to the fifth orbit, this transition of electron is called as T-fund series, fund series. Okay. This lies in which region? This in electromagnetic region, electromagnetic spectrum region. Electromagnetic spectrum region, you can say. Okay. This fund lies in far IR, far infrared region. One other thing you will be having, this you don't have in NCERT, but they may be asking in some competitive exams. So The sixth one is completely optional. If you want, you can learn, and sometimes it's not that important, but it's better to remember. It's Humphrey. Humphrey. This Humphrey series, in the series, when electron jumps from any higher orbit to the sixth orbit, this is called as Humphrey. This also lies in this. If this is far, you can say it as very far IR. So basically, if you don't want the specifications, if you forget the what is near and which is middle, which is far and which is very far, you just simply write it as infrared. That's it, IR. You can simply write it as infrared region. If you don't remember which is near, which is middle and which is far and which is very far, you just better write infrared. For all of them, you will get full marks. For your understanding, I wrote these keywords, and if you write, you will get a good impression by the examiner. Just note it down. Okay, I will draw one diagram for your better understanding here. Okay. It's completely for your understanding. It's also there in your NCERT. Equals to 1, n is equals to 2, n is equals to 3. N stands for shell, which I told you previously. N is equals to 4, n is equals to 5, n is equals to 6, and n is equals to 7. Here I am not going to mark the Humphrey because it's not correctly mentioned in your NCERT. So I just told you for understanding, so no need to remember this. When electron jumps from any higher orbit to first orbit, it's Lyman. So like this, the diagram will be like this. Okay, let us take till here only. It's Lyman. Okay, you just note down this. I'll extend this and draw for all of them Lyman, Balmer, partial bracket and fund. Let's take a screenshot. Okay. Okay. I'll extend this. You can see in your NCERT, but it's completely for your understanding. Okay, now this is Lyman. Electron jumps from any higher orbit. When an electron jumps from any higher orbit into second orbit, this is called as Balmer series, as you know. This n, these all are orbit numbers from first orbit to seventh orbit. You can extend this till n maybe anything. You can take there will be more number of shells, but we don't consider all of them since we don't have much space. So it's better to write. You can extend as many as shells you want, but it will look like this, and it is better to remember. From any higher, if the electron jumps from any higher orbit to third orbit, this is called as Paschen. Lyman, Balmer, Paschen. And if electron jumps from any higher orbit to the fourth orbit, it is called as bracket. And if electron jumps from any higher orbit, similarly to the fifth orbit, it is called as fund. For spelling sake, you can remember as P fund. Okay. you note down this. Meanwhile, this is very important, which I am going to write for your competitive exams. This is very important for your competitive exams. That is radius of hydrogen and hydrogen-like species. Radius of hydrogen and hydrogen-like species. This is given by both. These are the formulae given by the board, Neil board, and you will have some 3-4 formulas you need to remember, and you will regularly repeat in your JEE Mains, Neet and EAMCET exams. It is Rn. If we are talking about the nth orbit, then the formula of radius is Rn, subscript n. Rn is equals to 0.529 n square by z angstroms. This is the formula. Please note down the formula. Radius of the hydrogen and hydrogen-like species in the nth orbit. In the nth orbit, the radius of the hydrogen-like species formula will be Rn is equals to 0.529 into n square by z angstroms. 0.529 n square by z angstroms. If you want in meter, just multiply this angstrom. Since you know that 1 angstrom is 10 to the power of minus 10 meters. You can convert into SI units by multiplying it, with 10 to the power of minus 10 meters. Let us do an example. If we are calculating the radius of hydrogen-like species like lithium, that is Li2 plus, the atomic number will be 3. Okay. Then, and if you are calculating for second orbit, let us say, then Rn is equals to 0.529. N square is 2 square is 4. So n square by z, z is 3. N square by z angstroms. By calculating this, you want this 3 by 4. With the 3, 1.3. So 0.529 into 1.3 angstroms. So by multiplying, you will get the answer. And this is the way you need to solve this. Okay, you just calculate and comment me down the answer. You just take a screenshot. Okay. Now we are dealing with. Now we will be going to deal with the velocity of hydrogen and hydrogen-like species. Previously we saw the radius of the electron in the hydrogen-like species in nth orbit. Now we are seeing the velocity of hydrogen-like species in nth orbit. If n is the orbit, the velocity of electron in the nth orbit is v subscript n. Vn is equals to 2.19 into 10 to the power of 6 z by n meters per second. This is the formula. Z by n meters per second. This is the formula. Velocity of the hydrogen and hydrogen-like species in nth orbit is Vn is equals to 2.19. Vn is equals to 2.19 into 10 to the power of 6 z by n meters per second. Without seeing, you try to tell me. Vn is equals to velocity of electron in nth orbit. Vn is equals to 2.19 into 10 to the power of 6 z by n meters per second. Okay, similarly you will be having energy of electron, this is okay, velocity of electron. Similarly, energy of electron in hydrogen and hydrogen like species. Okay, energy of electron in nth orbit is Vn is equals to minus 13.6 into Z square by n square electron volt per atom. This is the formula. So energy of electron in hydrogen and hydrogen like species in nth orbit is En is equals to minus 13.6 into Z square by n square electron volt per atom. You just tell me, this is in electron volt per atom. Mostly the questions will be asked in the unit of electron volt per atom itself. Okay, you just tell me the formula. En is equals to minus 13.6 into Z square by n square electron volt per atom. Minus 13.6 Z square by n square electron volt per atom. Z stands for atomic number, n stands for orbit number. The orbit for which, in which the electron is present. And I am writing clearly, I am not erasing anything. Z square by n square, Z square by n square electron volt per atom. Okay, electron volt per atom. This is the formula of energy of electron in hydrogen like species. And similarly, you will be having you remember one thing, the total energy. If the total energy is E, if the total energy is represented by a symbol E, then total energy is equals to potential energy plus kinetic energy. Always you remember one thing, total energy E is equals to potential energy PE plus kinetic energy KE. So according to this, this is the law of conservation of energy. You will be learning in work power energy in physics. But this is all the basics of the physics and also the chemistry. In this chapter, structure of atom mostly deals with physics topics, which is much more interesting. Now, the potential energy formula is nothing but twice the total energy, and kinetic energy is nothing but the negative part of the total energy. Okay, I will write down here clearly. First, the potential energy PE, potential energy is equals to twice the total energy, and kinetic energy is equals to negative of total energy. If E is the total energy, where E is the total energy, where E is the total energy. If E is the total energy, the potential energy PE is equals to twice that of total energy, and kinetic energy is negative of energy. This is also valid for your gravitation chapter, where you will be having the same thing. If you know one thing, if you know the total energy formula, you can derive for potential energy and also for kinetic energy. You note down this and take a screenshot. Just note down this. Don't worry, we will do the questions based on this after the video. In this video, we are only concentrating on the basics and how we need to think when the question is given for your competitive exams, and also the theory required for your NCERT, that is board level. So we will practice a number of questions based on all the topics. We don't believe anything. At least one question after, at least 2-3 questions from each topic we will do. So note down this and revise the notes. Okay. Okay. Now we are going to the Actually, photoelectric effect I should explain you previously, but after explaining Planck's theory, you got some idea, and also we solved some moderate level question if you remember, where we linked the two formulas, that is C is equals to lambda nu, and also E is equals to h nu. Basing on these two formulas, we already solved the problems. So after this, I wanted to tell you this photoelectric effect. So I am telling the photoelectric effect now. Photoelectric effect. Photoelectric effect. This photoelectric effect states that the photons. Photoelectric effect states that the photons. What are photons? The photons are the particles which are present in light. Suppose this is some beam of light passing. This light will have some small invisible particles. These invisible particles are called as photons. A bunch of photons together form a light according to the particle nature of light. According to the particle nature of light, these photons are very small particles of light. Okay. Now this particle nature of photons is given by Einstein. Albert Einstein, who founded this photoelectric effect. Okay, because I am telling the scientist name because this Albert Einstein founded this photoelectric effect. And questions you may sometimes it's not that regular question based on which I am telling you. You may get the question mostly 99%. He may ask photoelectric effect directly, but sometimes he may tell Einstein effect. You will be confused that what is Einstein effect? Einstein effect is nothing but this photoelectric effect. In this, when suppose this is some metal piece. What is this? This is some metal piece. Okay, on this metal piece, when you pass the light, when you pass a beam of light, this metal will itself have some electrons embedded in it, and when this light of sufficient frequency nu is passed on light beam is passed on this metal, due to this light wave, this light will have some photons which I told you previously. These photons will have some energy, and this energy present in photons will eject the electrons outside with some kinetic energy Ke. You understood my point? You will have some metal. Suppose this is some metal, and on this metal, if the light is falling, okay, if the light is falling, it's like this. When this light falls on this metal, the electrons which are present in this metal will eject because the light will have some energy. The energy means the light will have kinetic energy, and they will hit not kinetic energy, some energy. According to Planck's theory, you will be having E is equals to h nu, which I told you. Suppose this is metal, the light will fall on this metal, and the energy in photons will eject the electron from this metal surface, and it will move with the kinetic energy like that, which I throw the marker now. Now the light rays will come like this, hit this metal surface, and the energy which is present in photons will transfer to the electron present in the metal and eject the electron outside. So this is the concept where the photoelectric effect takes place. The metal here used are sodium, lithium, potassium, calcium, and so on, etc. But instead of writing etc., we can end here itself, because in most of the cases of photoelectric effect, we will be using the metals are sodium, lithium, potassium. It's also not calcium. Sometimes they will use. In most of the cases, you will be using sodium, lithium, potassium for this photoelectric effect. So according to the law of conservation of energy. What you know? According to the law of conservation of energy, what happens is the energy can neither be created nor be destroyed. Right? Energy cannot create and also it cannot be destroyed. It should go somewhere, but it should be there. That's the theory of law of conservation of energy. Means energy will not go waste. It will be there in some form. It will be transferred in some other form. Here is what that is happening. Now the photons which are falling here, on the metal surface will have some energy E. Let us say, okay, this energy is equal. This is the total energy. From anywhere we are not getting the energy, only from the photons we are getting the energy. So a total energy E will be converted into the kinetic energy, right? I told you, right? When photons hit the metal surface, electrons will be ejected. These electrons will be ejected with some force, with some energy. This is called as kinetic energy. Okay, and not only this, it will be ejected with some kinetic energy. But to remove the electrons from the metal surface, you will require some minimum energy, right? This minimum energy with which the photon hit the electron is called as work function. This work function is represented by the symbol phi naught. Okay. What happens is the metal itself will have electrons present in the metal will itself have some energy called as work function. This is the proof I am doing so that you can better understand. Means simply, if I tell in one statement, the photons will have some energy they will hit electrons, and that energy in photons will be converted into kinetic energy of electrons and they will eject out. Before that, electrons needed some minimum energy to just move outside, right? That is called as work function. Work function is the minimum energy required to just eject an electron, not to move, just throw out of the metal surface is called as work function. You don't need to remember this like this formula. I will tell you one formula easily. H nu minus H nu naught is equals to half mv square. Okay. This is the only formula you need to remember. In physics, you will be learning the law of conservation of energy, that is work energy and power. But don't remember this like this. Again, you will be confusing what is E, what is kinetic energy. Okay. After transposing here and there, you will get this. The main formula of photoelectric effect is H nu minus H nu naught is equals to half mv square. H nu minus H nu naught is equals to half mv square. Again, you repeat it once again. H nu minus H nu naught is equals to half mv square. Where the H nu is called as the energy of photon, energy of photons, and H nu naught, which I told you previously, is called as work function. And half mv square, which is there, half mv square is called as kinetic energy. Ke, it's represented by Ke. This Ke is called as kinetic energy. So our formula is H nu minus H nu naught is equals to half mv square, and H nu is called as energy, is nothing but energy of photons. H nu naught, not there means work function. If there is not, you observe in here, you have to observe here. If there is not, then it is work function. Half mv square means kinetic energy. The formula of kinetic energy is this. This is only the formula of kinetic energy. Kinetic energy is nothing but half mv square, where m is the mass and v is the velocity. Velocity means it's like speed. Okay, speed of the electron. Now, what is nu naught? This nu naught is called as threshold frequency. Similarly, like work function is the minimum energy to eject the electron from the metal surface. Similarly, nu naught is a threshold frequency. So what is threshold? The threshold is one thing where you will be having in home when you go outside and come inside, between one thing will be there, that is called as threshold. Okay, this similarly, if you want to cross it, you need to minimum have threshold energy. Similarly, this threshold energy here is nothing but work function. Okay, the minimum energy required to eject electron, the kick out the electron from the metal surface is called as work function. Okay, now nu naught is called as threshold frequency, means the minimum frequency. Nu naught is minimum frequency or threshold frequency. This is also called as sometimes or cut off. You will be having like cut offs for your Jeemains and Neet. They are similar to that that you will be having cut off frequency. Is also called as threshold or cut off frequency. Means it's minimum frequency. Means you will be having cut off like mains cut off. If you clear the cut off, then you will be qualifying to advance. Means it's similar to that, it's cut off. If you cross that frequency only, the electron will ejected. Otherwise, photoelectric effect won't work. It will not be successful. Okay. You see, if one condition is there here, if h nu, that is energy, is greater than h nu naught only, photoelectric effect will work. Okay, if h nu naught is greater than h nu, means if h nu is less than h nu naught, then no photoelectric effect, no photoelectric effect. Okay, there is no result of it. If this h nu is greater than this h nu naught only, photoelectric effect takes place. If this is small, h nu is smaller than h nu naught, it will not take place. Take a screenshot. It's if, okay? It's if. Okay, take a screenshot. I am taking, since this is first chapter, I am going a little bit slow, but from your next chapter, it will be a habit of learning fast. So from your next chapter, I'll increase the speed. So since this is your first class, you can you should learn this slowly. Okay. It's not that from next video I'll run away, but from next time we'll go little bit. If this is 0.98, if this speed is 0.8, if now I am telling it speed some 0.8, we'll increase to 1. That's it. Not that like 2, 3. In YouTube you will be having play speed, right? Now I am telling 0.8. After that it will be 1 or 1.1 maximum. Okay, I'll not increase that much. Now we are going to the wave nature. Now in this photoelectric effect, what you have learned? You tell me. In photoelectric effect, you have learnt about the particle nature of light. Suppose this is the light, this is sunshine. For example, it is coming in your window inside the house like this. Then this is the particle nature we have only studied. From now, you will be understanding the wave nature of light, and also wave nature. If light have wave nature, always then electron will also have wave nature. So we are going to deal with wave nature of light. Wave nature of light and also electron. Electron will also have wave nature. So wave nature of light and electron. Wave nature of light and electron. First one we are going to deal with is de Broglie principle. Principal here doesn't mean it's your headmaster, it's a rule, okay? The wave nature of light of electron and wave nature of light and electron, first thing you will be having is de Broglie principle or de Broglie wavelength, de Broglie principle, okay? In this de Broglie principle, what he gave is, you in NCERT you will be having some one big page. It's no need to run, no need to study whole big page. Instead of it, in single formula I'll explain all the theory which is there in your NCERT, which is needed. Okay. In de Broglie principle, you will be having wavelength lambda is equals to h by mv is equals to h by t. This is the only formula. Means this is the only formula where the people tell this is de Broglie principle. Simply the de Broglie principle is lambda is equals to h by mv. From this only we will derive this. Okay, no worry. Initially you learn that de Broglie principle is nothing but lambda is equals to h by mv. Repeat it. Lambda is equals to h by mv. Where this lambda is called as de Broglie's wavelength. This you will be telling about this de Broglie wavelength, okay? And h is, you know that it's Planck's constant. Planck's constant. Okay? And mv, I think you will get some idea what is mv. I previously studied about this. It's nothing but momentum. The product of mass and velocity is nothing but momentum. Momentum is symbolized with the letter small p. Okay, small p. The formula of momentum is P is equals to mv. The formula of momentum is what? The product of mass and velocity. P is equals to mv. So P is equals to mv, where m is mass and v is velocity. See, whenever in question, I will write the note, however, but this is very important. Previously I used to confuse, and so many of my friends also confuse in this questions of this de Broglie principle. Here mainly you will be having this lambda. You will be having two lambdas, two cases. First case is where you used normal wavelength of light. That is wavelength of light. This is de Broglie wavelength which is produced by the movement of electron. There, the light of electron. Okay, means the light which is there. We will be having the light. This light will have some wavelength. That lambda means their wavelength, normal wavelength. Here it means de Broglie wavelength. De Broglie wavelength will always be produced in the moving particles. Okay, this is most of the questions you will confuse by giving normal wavelength. You will tell normal wavelength, and if you tell about some movement, the word movement or moon, velocity, if you use like this, you should get the point in mind that lambda means de Broglie wavelength in this case. That's it. mv means it's nothing but momentum. Okay, it's momentum. Okay, I previously wrote P, right? So since P is equals to mv, lambda is equals to h by p. Means, but the one thing which is mentioned in your NCERT is lambda is inversely proportional. Since this h is a constant, by removing the constant you will get proportionality. So lambda is inversely proportional to m if velocity is constant. If velocity is constant, is it inversely proportional to mass. If mass is constant, it's inversely proportional to velocity. That's it. You can instantly derive with this formula itself. Lambda is equals to h by mv. If mass is constant and Planck's constant is always a constant, so lambda is inversely proportional to v. If velocity is constant, lambda is inversely proportional to mass. If velocity is constant, then according to this proportionality, if mass increases, then wavelength decreases. So in the real world, if you see for macroscopic objects, macroscopic means which you will be seeing with your eye, normal eye. If the mass increases, the objects which you see in your real world will have high mass. Since the mass is very high, okay, the wavelength will be low. So even if you move the objects, which have high wavelength, which have high mass, there will be no wavelength. But if you move some very small particles like electrons, the mass is, in that case, for electrons you will be having the constant velocity. Velocity will be constant, the same case, and the mass will be very less. So wavelength will be high. This is the conclusion given by the de Broglie. Similarly, if the mass is constant, it's inversely proportional to velocity. You don't need to bother about this proportionalities. We only focus on this concept. Okay. Also, there is another formula for wavelength, de Broglie wavelength. Lambda is equals to h by under root 2mke. It's 2. Okay, I'll write properly. Okay, this lambda is also equals to h by under root 2mke. Lambda is equals to h by mv. Lambda is equals to h by p. Lambda is equals to h by under root 2mke. Lambda is equals to h by under square root 2mke. Lambda is equals to h by under root 2mke. Where k is nothing but kinetic energy. And m is nothing but mass of electron. M is nothing but mass of particle, you can say. If it is not electron, then we can better say it as some particle. Mass of particle. Okay. Mass of particle. Okay. Lambda is equals to h by under root 2mke. If you remember this formula, you can directly substitute the values and get the solution of this. Okay. If you don't remember, you need to, there will be some big procedure, some 3-4 steps you will be having. If the relation between momentum and kinetic energy is P is equals to under root 2mke. You will be having derivation, I remember this. So P is nothing but under root 2mke. In place of P I substituted this. If you want that how we got this under root 2mke, I'll simply tell you, momentum is nothing but mv. What is kinetic energy? Kinetic energy is half mv square. Okay. If we, in this v square we can write as m into v. Okay. V multiplied by v. In place of this mv, if you substitute kinetic energy, momentum p value, it will be pv. If you multiply and divide by m, you will be getting kinetic energy is equals to, again mv is p, so p into p square by 2m. According to this, p is equals to 2mke under root 2mke. From this much step you need to do, so it's a long procedure. Other than this, you can remember this formula. Okay, if you want, you can note down. This you need to at least to do for one time, such that you will be improvising your solving skills. Okay. Okay, take a screenshot of this. Now we are going to, okay, again you will be having some another formula of this de Broglie wavelength, h by under root 2mqv. It's used in modern physics. You better note here only, instead of having more pressure in your 12th, you try to remember most of the things now itself, since you will be having the board pressure in 12th. So the formula of de Broglie wavelength is lambda is equals to h by under root 2mqv. Okay, lambda is equals to h by under root 2mqv. What is this q? Q is nothing but charge of particle. It may be electron also or any other particle. Here V does not mean velocity. V means voltage. Voltage which will be provided in your question itself. Okay. Now, this is the solving strategy. We'll say solving strategy. This is the solving strategy In case of de Broglie wavelength, if the keywords in question, are like movement, velocity, change in position, randomness, etc. related to the movement. Means if you observe the keywords such as movement, velocity, randomness, change in position, velocity, or there are some other words which may be created by the examiner in the question, in your examination. So if you get these type of words related to the movement and velocity, you blindly think about this de Broglie wavelength. De Broglie wavelength, you will be having lambda symbol. You just think of this wavelength, de Broglie wavelength. Okay, if these keywords related to velocity, change in position, if these are not mentioned, then only in that case you consider the normal wavelength. Okay, most of them will confuse between normal wavelength and de Broglie wavelength. De Broglie wavelength only comes into the play when there is movement and velocity related to some body. Okay, it's very important. Not if I mark 100 times also, it's more important. So you just note it down. Okay, you just note on this. Okay, now in this wave nature of light, the second conclusion is given by our Heisenberg. Okay, this Heisenberg gave Heisenberg uncertainty principle. Okay. In this wave nature of light, first thing you have learned is de Broglie wavelength. Second thing you will be going to learn is Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. Okay, this uncertainty means error. Uncertainty means it's error, means the thing which is wrong. Okay. According to this, you will be having principle. You just remember this point for your board exams or for school level exams. It is impossible to determine position. It's impossible to determine position and momentum of electron simultaneously this is the word simultaneously, means at the same time. Okay, in this Heisenberg uncertainty principle states that it's impossible to determine. Heisenberg's uncertainty principle states that it's impossible to determine the position and the momentum of the electron simultaneously. Means this position and momentum cannot be determined at the single time. They may be determined individually position or individually momentum, but combining both you cannot determine both at a time. So this is the principle, and this is numerical for numerical purpose. Okay, as a formula you can take this. In formula you will be having you will be having delta x into delta p must be greater than or equals to h by 4 pi. What is the formula? Formula of Heisenberg uncertainty principle is delta x into delta p must be greater than or equals to h by 4 pi. Right? Delta x into delta p must be greater than or equals to h by 4 pi. This delta x is nothing but change in position. You can say change, or better word according to this principle you can say uncertainty. Uncertainty, right? This delta x is nothing but uncertainty in position, and similarly delta p is nothing but uncertainty in momentum. You can, as you know, for h is Planck's constant, and this 4 pi. This 4 pi is a constant. This 4 pi is a constant. H by 4 pi is a constant. For numerical purposes, you need to remove this proportionality. Sorry, you need to remove this equality and take as delta x into delta p must be equals to h by 4 pi. You need to take equality here, because in numericals you don't have option like using inequality greater than less than. So you need to take is equals. This is also some solving strategy, solving trick you can say. This is also some solving trick. In numerical purpose you should take delta x into delta p must be equals to h by 4 pi. Since momentum is nothing but mass into velocity, you will be having, since mass will remain constant, the velocity will have some error. So delta p is nothing but m into delta v. Okay, I am writing continuation of this. You can write this formula of Heisenberg uncertainty principle as delta x into delta mv. Okay, m into delta x into m delta v must be equals to h by 4 pi. So by transferring m there into the denominator, it will be delta x into delta v must be equals to h by 4 pi m. Delta x into delta v is equals to h by 4 pi m. This is another formula. If you don't want to derive, you can remember this also. Where delta v is change in moment, change in velocity. Okay. Here you will be learning now quantum model of atom. This is quantum model of atom. In this quantum model of atom, since we understood that there will be two nature of atom, this particle nature and wave nature. The particle nature of atom we already learned in Bohr theory. Now we are going to understand the quantum mechanical model, that is wave nature of particle. This to explain this quantum model of atom, Schrödinger did some experiments. To explain this quantum model of atom, Schrödinger did some experiments and found the solution of this quantum mechanical model, and he gave this Schrödinger equation. Dou square psi by dx square plus dou square psi by dy square plus dou square psi by dz square plus 8 pi square m by h square into E minus V into psi is equals to 0. This is a very big equation given by, yes, it is 8, not 8 pi square m. It is 8 pi square m pi square m by h square into E minus V into psi is equals to 0. This is a very big equation given by Schrodinger, and you don't no need to actually remember this. You just understand by if you just improvise your visualization skills by seeing. If you are able to mark the option, it's very good. In board exams and JEE mains exams, they may ask the question, which of the following is a Schrodinger equation, like that, or which of the theories, which of the conclusions given by Schrodinger are related to him, like that. So they may ask. And also there is some another equation, that is E psi is equals to H psi. This H here is called as Hamiltonian. Okay, E psi is equals to H psi. This Hamiltonian is related to high level mathematics. We don't deal with here in this 11th and 12th. So we don't know this. These two are the Schrodinger's equation. This E psi and H psi. E psi is equals to H psi is a very easy thing to remember. And this psi, PSI. Okay, this symbol is like Trishul. It's psi. Okay, psi means wave function. Psi means wave function. Okay. Now about this wave function, we will see wave function. Okay, we will see solution of wave function. We will see the solution of wave function. In this solution of wave function, means solution of this psi. There are some rules related to the wave function solution. It should be finite. It must be single valued. Wave function must be continuous, and its first derivative must be continuous. Okay, these are the four solutions of wave function. For these wave functions are derived from this Schrodinger wave equation. We don't need to derive this. If we derive, it will not be sufficient, and we don't require this. It deals with very high level mathematics. So you just remember these 4 points. These are important for both NCERT, also JEE and other competitive exams. Okay, the solution of wave function is only possible in the 4 cases. This wave function must be continuous, wave function must be single valued, wave function must be finite, and wave function first derivative must be continuous. Okay, you just note down this. You will be having here one. Here you will be having. We previously studied about this psi. Now the modulus of this psi square is nothing but probability density. Okay, the modulus means positive value of the psi square. Modulus of psi square is nothing but probability density. The probability density is like how many electrons are there per unit volume. This modulus of psi square, that is probability density, is nothing but how many electrons are there at this specified places. So modulus of psi square is nothing but how many electrons are there at the specific place of electron. If you take 1s orbit, you don't understand about this, what is S, P, or let us let us take this one S. S means it's a very small atom. You just understand like that. In future, in after some time, you will be learning about the different different atomic numbers. Sorry, different numbers of quantum mechanical model. Different quantum numbers we will be studying. This comes under azimuthal quantum number. I will tell you. Okay. For this 1s orbit, if you plot a graph for modulus of psi square, that is probability density versus radius of atom. If this is the big atom, we are assuming like that, and this is the positive nucleus, and here the electrons will be very high. The density of electrons is very high because these electrons are negatively charged. Protons present in nucleus are positively charged, they attract. Therefore, there will be more number of electrons surrounded here near the nucleus. But as we go forward, these decrease and become very less. So the graph of psi square, that is probability density versus if you plot a graph between probability density psi square versus radius, plot a graph between probability density versus radius of atom, the graph will be like this. It will go on decrease for 1s orbital, okay, 1s electron. And if you consider for 2s orbit, it will be like this. If you assume, okay, I will drop this. So just for your understanding, this is first nucleus, this is first orbit, this is second orbit. Here also, similarly in 2s orbit, here also the electron density will be very high. Okay, it will be high, and at some point you will be having empty space, means no electrons. This point is called as node. N-O-D-E, node. Means node is a point where the probability of finding an electron, that is modulus of psi square, is equals to 0. You may feel difficult in this, but if you face any difficulty, you just rewind the video and see. So the place in the 2s orbit, the place in which the 2s atom, where the probability of finding an electron, where we will find the electron is 0 completely, there will be no electron, that place is called as node. Okay, if the probability density modulus of psi square value is 0, that is called as 2s node. Okay, if you plot for 2s orbit, the graph will be this is modulus of psi square, and this is radius. This will be like this, it will fall. At some point it will become 0, again it will go to some maximum and it will decrease. It's like this. This point is called as node. Okay, just note down this. You will be having after this in the next chapter in the next class we will be learning about this. We will be learning about the quantum numbers you will be having, and also the electronic configurations. Now we will learn more deeply about these nodes. Okay, node. Okay, we will be seeing about this node. In nodes you will be having two types, that is radial node and angular node. We don't need to go more deeply about this radial node and angular node, and we actually don't require the meaning of it. So nodes are of two types. You just remember that node is a space where the probability of finding an electron is 0. Okay, these nodes are of two types. That is, first one is radial node and another is angular node. This formula of the nodes, number of nodes. number of nodes, formula is number of nodes means total nodes, number of total nodes is equals to n minus 1. The formula of total number of nodes is n minus 1. What is this n? N means, here the n means the shell or orbit number. In 1s, what is n? N is 1. In 2s, the orbit number is, any number is 2. In suppose 3s, if we take 3s, n is 3, like that. Okay, it's the number which is written before this alphabet. Okay, and if you take number of radial nodes, okay, before learning this you just note down this. Number of angular nodes is equals to L. What is this L? I will tell you after this class, where you will be learning about this, where you will be learning about the quantum numbers. You will be having this S, L, D, F. Okay. If you don't have clarity, you skip this point and learn that and come back here. Okay. So number of angular nodes are nothing but formula is L. L stands for, it's azimuthal quantum number. Azimuthal quantum number. Okay. Number of radial nodes is nothing but minus 1. If you don't remember, the total number of nodes is equals to radial nodes plus angular nodes. So number of nodes n minus 1 is equals to x plus L. So it's nothing but n minus 1 minus L. So number of radial nodes is nothing but n minus 1 minus L. This is the formula. And total number of nodes formula is n minus 1. Okay. Friends, now I am going to explain about this quantum numbers. Previously I explained the Heisenberg uncertainty principle, de Broglie wavelength, and about the nodes. Right? Now I am going to deal with quantum numbers. The quantum numbers are of 4 types: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. Okay. Principal quantum number is represented by the letter small n. Azimuthal quantum number is represented by letter small l. Magnetic quantum number is represented by ml, or sometimes it is represented by normal m also. And spin quantum number is represented by s or ms. Okay. Here the s is a subscript. Similarly, here l is also a subscript. M stands for magnetic. Magnetic quantum number is represented by ml. Spin quantum number is represented by ms. First quantum number is principal quantum number, represented by small n. This principal quantum number tells about the size of the orbital. Okay, means the orbital is of which size. Suppose we have one orbital. So we have one subshell, say 2s. If you want to tell the size of the 2s orbital, size of the 2s subshell, then you need to consider the principal quantum number. If this is 1, if this is 1s, between 1s and 2s, the size will be big. 1s will be, suppose, like this, 2s will be like this, it's big. So principal quantum number tells about the size of the orbital. Okay, suppose this is 1, here the s is same, means the azimuthal quantum number is same, but the number is changing, the number is increasing, means the principal quantum number is increasing. By that we can say the size of orbital is increasing. So the principal quantum number n tells about the size of the orbital. Now it is indicated with the letter small n, as I told you. Now this is the important formula. This principal quantum number tells about the total number of orbitals that can be filled in a shell. Suppose there is first shell. Suppose there is first shell. In the first shell, how many number of total number of orbitals it can be filled? If you get a question, then the answer is n square. Here n is 1, so 1 square is nothing but 1 again. So the total number of orbitals that can be filled in one shell, first orbit is 1 square, that is 1. Therefore, in first shell you only have one orbital, that is 1s. Okay. It's just an example. You just need to remember these points. I wrote you before so that I can explain each of the point clearly and give a better example. Okay. It tells about the total number of orbitals that can be filled in a shell. Okay. N square. The formula is n square. Okay. I also want to write one more point here. That is, in one orbital, 2 electrons are present. Actually, this point is very valuable since you will get nowhere, and in NCERT also you don't have this point. It's a key point. So many people confuse that in orbital how many electrons will be there. By doing some more problems, I got some conclusion that in one orbital you will be having 2 electrons. Okay, in one orbital 2 electrons are present. Therefore, since the total number of orbitals that can be filled in a shell is n square, the total number of electrons that can be filled in a shell is 2n square. Since the number of orbitals, since electrons are double than the number of orbitals, it's twice of n square. Okay, if the number of orbitals are n square, then total number of electrons are 2n square according to this point. You don't need to remember separately. If you remember this point, you can automatically derive this formula immediately. Okay, and this is also very, very important, and some questions may be asked from this point. The n values starts from 1, 2, 3, 4 and so on, similar to natural numbers. Okay, you have natural numbers and whole numbers in mathematics. In natural numbers, the values starts from 1, right? Whole number starts from 0, 1, 2, 3 and so on, whereas natural number starts from 1, 2, 3, 4 and so on till infinity. Similarly, the n values in principal quantum number starts from 1, 2, 3, 4 and so on, similar to natural numbers. This is an important point to remember. It's a good comparison. If you remember the things by doing comparison, you can easily remember. Okay, the corresponding shell names. The corresponding shell names for values of n are as follows. Okay, I made this table. The different names are given to the different shells. Suppose this is the atom. I'll draw this. Suppose this is the atom and these are the shells, as you know. According to this, these shells have names. The corresponding shell names for the values of n means the different shell names are different names. The first shell, n value is 1. The name is K. Shell name is K. This is first shell. This is nucleus, not first orbit. First shell. This name is K. If n value is 1. If n value is 2, L. N value is 3, K, L, M, N. You just remember as K, L, M, N. Okay, these are the shells. K, L, M, N are the shells corresponding to K is equals to 1, L is equals to 2, M is equals to 3, N is equals to 4, and it continues. We don't have another names for 5, 6, 7 and so on. Till this only we have according to the modern periodic table. So 1 is K, 2 is L, 3 is M, 4 is N. Also, n indicates the total number of subshells that can be filled in a given shell. Okay, means that if the n is a principal quantum number, then how many subshells will be there in a given shell? You can easily get the value of subshells by the value of n which you have been provided with the shell subshell. Okay. Suppose you have 4s orbital, 4s subshell. Okay, if you have 4s subshell, then n indicates the total number of subshells. Here, what is 4? What is n? It's 4. So here n is 4. Therefore, the total number of subshells that can be filled is 4. That's simple logic. Because in fourth shell, suppose if there is a fourth shell, in fourth shell you will be having S, P, D and F. All the 4 can be filled. According to this, you can say the total number of subshells will depend on the number of n directly. These are not exactly examples, but I created examples for you. Okay. You don't need to write these examples what I am writing and dubbing here. You need to write these points and remember them for your exams. Okay, now, second is azimuthal quantum number L. Okay, it takes the values from this azimuthal quantum number L takes values from 0 to n minus 1. So azimuthal quantum number L takes values from 0 to n minus 1. Okay, if the value of n is 5, let us say example n is equals to 5, you note on this. L values are from 0 to n minus 1. This is one formula you can say. It takes the value from 0 to n minus 1. So L values are 0, 1, 2, 3, 4. 5 minus 1 is 4. So till 0 to 4, all values are possible here. Also, it determines the shape of the orbital. This azimuthal quantum number determines the shape of the orbital. Now we are going to study about the different subshells. Previously I told you about this azimuthal quantum number L, right? In this azimuthal quantum number L, which decides the shape of the orbitals, you will be having corresponding S, P, D, F according to their azimuthal quantum number values. There is 0, 1, 2, 3 and so on. Now S subshell has only one orbital. S subshell has only one orbital, that is S. Whereas P subshell has 3 orientations. One is along x-axis. If this is the coordinate plane, this is x-axis, this is y-axis and this is z-axis. Actually this x and y you can imagine in one paper. Z-axis will be coming outward like this. Okay. Similarly, this P subshell will have 3 orbitals, Px, Py and Pz. And D subshell will have 5 orbitals aligned in different positions, that is dxy, dyz, dzx, dx square minus y square, dz square. Again repeat it, dxy, dyz, dzx, dx square minus y square and dz square. This has 5 orbitals, and we don't have any relation with F subshell. You don't see any questions based on the F subshell even in advanced level. Now note point is S orbital has no orientation, specifically because since it is spherical in shape, S orbital is spherical in shape, so you don't have in separate, you cannot place it in the coordinate planes, because if you even place you will get the same orientation. So we have only one orientation for S orbital, and there is no orientation specifically for coordinate planes. Okay, so S orbital has no orientation specifically for coordinate planes. So not for its in coordinate planes. In coordinate plane. And we have 3 orientations, because you have studied that ML has 2L plus 1 values. The value of P is 1. So value of P is L is 1. So 2 1s are 2 plus 1 3. Similarly, D subshell will have a value L is equals to 2. Yeah, I told you right. 0 means yes, 1 P, 2 D, 3 F. So ML is total number of possible values is 2 into 2 plus 1. 2 to the 4 plus 1, 5. So you have 5 orbitals. Okay. This formula is used to find the different orientations of the orbitals. This is proved, and we don't need to prove. I am just telling you for your understanding. Now, see this example. Write down all possible quantum numbers for the following orbitals, which you have studied the 4 quantum numbers. So based on this, you need to write down all possible quantum numbers for the given orbitals. Okay. For 4p orbital, the value of n, that is principal quantum number, is always a value which you will be writing first. That is 4, n is 4, L. Since we know that L value of p is 1, and ml values are from minus L to plus L, that is minus 1, 0, plus 1. Since I told you previously in the points, if you have any doubt, you just check that points and by rewinding it. So this takes from the ml values takes from minus L to plus L, that is minus 1 to plus 1, which includes 0 also. Similarly, 6s has principal quantum number 6, principal quantum number 6, azimuthal quantum number for s orbital, for s subshell you will be having azimuthal quantum number 0, ml is 0, from minus 0 plus 0, 0 does not have any direction, so you can write 0 directly. So 7d has principal quantum number 7, azimuthal quantum number is 2, and magnetic quantum number ml will take values from minus 2, minus 1, 0, plus 1, plus 2. These are the values taken by 7d orbital. Now let us go to this, very important for your JEE mains level exams. You will be finding many questions based on the energy of the two orbitals. So this is called as the rule which we are going to deal with is called as n plus L rule or energy rule. Okay, what is it? N plus L rule or energy rule. The energy of the orbitals is always determined by the formula of n plus L. Energy of a given orbital you can always determine by using the same formula, that is n plus L. What is n? N is called as principal quantum number, L is called as azimuthal quantum number. So n plus L of a given orbital gives us the energy of it. Okay. If n plus L is less, means if n plus L values is less, which implies energy is less. The rule itself says that n plus L or energy means the same. So if n plus L is less, then energy is less. If n plus L value is more, then energy is more. Suppose n plus L is some 3 in one case, and in another case n plus L value is some 5. Which has more energy? 5 has more energy than 3. Since n plus L is more, here energy is more, here n plus L is less, so energy is less. And if n plus L, exception, this is one exception, if the n plus L values of the two given orbitals is same, then how can you determine which has more energy and which has less energy? See this exception, it's very, very important. If n plus L of two orbitals is same, okay, then the orbital with more n value will have more energy. If the two orbitals are given of a given atom, then the orbital with more n value, which has higher n value, will have higher energy. Okay, and with the less n value will have less energy. Okay, example, between these the following, which have more energy, 2p and 3s, which has more energy, 2p. Okay, I'll write down here. You just note the question here, and I'll write the solution since I don't have space here. Just note down, I'll write that. 2p. 2p. In 2p, you will have n value is 2, L value is 0, 0 is for S, 1 is for P, 2 is for D, okay, and 3 is for F. According to this, L is for P is 1. So according to n plus L rule, 2 plus 1 is 3. So here n plus L value of 2p is 3, and 3s. Another one is 3s. N value is here 3, n value is 3, L value is 0. For S it is 0. So according to n plus L rule, 3 plus 0 is 3. These both have, this is an exceptional question which I gave you. Since both have the same n plus L value or the same energy, then since n value, if n value is greater, you will be having more energy. So in 2p and 3s, which has more n value? 3s has more n value. Since 3s has more n value, 3s has more energy than 2p. We can conclude this. 3s has more energy than 2p since n value of 3s is greater. Now let us go to degenerate orbitals. What are degenerate orbitals? Degenerate orbitals are the orbitals having same energy. Degenerate orbitals are the orbitals having same energy, that is same n plus L value. If the two orbitals like here 2p and 3s, since 2p and 3s have the same energy, that is same n plus L value, they are called as degenerate orbitals. Okay. Degenerate orbitals are the orbitals having same energy and that is same n plus L value. If the same n plus L value is there, then you can say the given orbitals are degenerate orbitals. That is same n plus L value. So according to this, if you take an example of degenerate orbitals, this 2p and 3s orbitals are degenerate orbitals since they have same energy. We cannot say it's same energy but same n plus L value. If same n plus L value, it means same energy. By taking electronic configuration, we take a different case where we will be seeing that greater n value or smaller n value, but those have same n plus L value are considered as degenerate orbitals. Now I am going to tell you about the shielding effect. This shielding effect is also called as screening effect. According to this, listen carefully. If you want definition, you can create your own definition. So shielding effect, by listening my points, you can note down directly. Shielding effect, this is also known as screening effect. The nucleus which is present at the center of the atom will have positive charge, whereas the electrons surrounded in the orbits will have negative charge. Since negative and positive attract, so the orbitals the orbitals having electrons will attract towards the nucleus and try towards the nucleus, and the centripetal force will be developed in it. Okay, apart from that, the electrons which are present in near orbits to the nucleus, they will be more attracted or more strongly bonded to the nucleus. Whereas if you consider here the nucleus attraction will be more, here somewhat less, here more less, here more, very less, because since these electrons which are present nearer will directly attract towards the nucleus, whereas here the electrons which are present here will due to the electrons which are present in earlier orbits, these consume some part of the positive charge, due to which these electrons will have some reduced positive charge. Similarly, if you go to the outermost electron, that is valence electron, the positive charge experienced by the outermost electron will be less. So this decreasing in positive charge or nuclear charge by the outermost electron is called as shielding effect. This shielding effect is an effect in which the outermost electron will not experience a complete positive charge by the nucleus due to the presence of inner electrons. This is the only definition. If you want, you just rewind the video for 10-20 seconds and listen it again and write down. Okay? If you want, I can write, but we should reduce the time. We should learn. We should be smart. Okay? Now, pattern of electronic configuration. Pattern of electronic configuration. According to a pattern of electronic configuration, according to the Aufbau principle, Pauli's principle, and Hund's rule of maximum multiplicity, according to these three rules, the pattern of electronic configuration has been developed. Okay? This pattern of electronic configuration, this is developed by this Aufbau principle, Pauli's exclusion principle, and Hund's rule of maximum multiplicity. This you better study in NCERT, and this is not much important. You need to study these rules and mostly you won't be asked. For competitive exams, it's not more important. You need to focus on solving the problems directly by remembering this order, other than learning all the rules and getting headache. Okay. So pattern of electronic configuration will be like this. According to Hofbauer, Pauli said rule of maximum multiplicity. So you just remember this. Okay, if you don't understand, I marked it like this. It's a given first 1s, next 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6p, 7s. You will be also having 6d, 6f and so on. But according to our modern periodic table, you will not be having 6d or 7p orbitals because the new elements are still not discovered. So, if you want to remember this order, you just write down like this: 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6p, 7s. Okay. According to this, you just write down vertically like this, all of them. After writing, the energy will increase like this. Okay. From here to here, the energy will increase. 1s, after filling 1s, you will be filling the electrons of 2s. After 2s, you will be filling the 2p. After 2p, you will be filling 3s. You draw the line slantly. So one by one, you need to fill. First 1s, next after like this slantly 2s. After filling 2s orbital with 2 electrons, you will be going to 2p. You will be filling 6 electrons in p orbital of 2. Next 3s, next 3p, 4s. After that 3d, 4p, 5s. Okay, after 5s, 4d, 4p, 6s, 4d, 5p, 6s. After that 4f, 6, 5d, 6p and 7s. Okay. First write down all of them. From if you go like this, you will be increasing the order of energy. Okay. You can remember like this, or after solving some problems, you will be easily remembering this order electronic configuration. That is 1s. You just, if you don't remember like this, if you feel it clumsy, you just need to remember as 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d and 6p. If you don't remember, you can. It's an easy process. In the initial stage, I used to remember like this. First write all of them: 1s, 2s, 2p, 3s, 3p, 3d, like that and so on. And slantly, if we go, the energy will increase one by one. Okay. 1s, again I will be telling you. See, 1s, after you fill 1s, you need to fill 2s. After 2s, you need to go here. Okay. And again you need to move in this direction. Okay. You need to move in. I will draw this mark so that you will be understanding. You need to move like this from here to here. After filling 1s, you need to fill 2s. After 2s, you will be going here 2p, 3s. After 3s, again 3p, 4s. After this 3d, 4p, 5s. And if you draw again one line here, it's 4d, 5p, 5, 6s, 4f, 5d, 6p and 7s. You need to go this slantly, so you will increase the order of energy. Okay. So according to this only, I written here 1s first you fill, next 2s, after 2s 2p, 3s, 3p, 3s, 4s, 3d, 4p, 5s, 4d, 5p, 6s and so on. Okay. And this is only derived based on your N plus L rule. Since according to N plus L rule, according to N plus L rule, which have less energy should be filled first. So, according to this Pauli's exclusion principle, what he told is the orbitals are filled in the increasing order of their energies. You just study in your book NCERT, because explaining this is not worthful, I guess, because you will not be having any of the questions based on these principles. So, I am telling this Pauli's principle for you. You just note down. Pauli's exclusion principle states that electrons are filled in orbitals in increasing order of their energies. Means, according to him, the orbitals are Pauli's exclusion principle states that the electrons are filled progressively from less energy orbitals to the higher energy orbitals. So, electrons are filled in increasing order of their energies. Okay. According to this, so 1s has 1 plus 0, that is 1, or 2s has 2 plus 0, that is 2. You'll be having like this increasing n plus L values. It's like this, from less energy orbitals to the higher energy orbitals, you'll be filling electrons. Okay. Always remember one point: one orbital will only fill maximum of 2 electrons. That's it. If it have different orientations, you'll be having more number of orbitals, thereby more number of electrons. Okay. Let us see one example. That is carbon electronic configuration. Carbon has atomic number 6. So electronic configuration according to this is 1s2. Since you have atomic number 6, so you will be having 6 electrons. First, you should fill in lower energy orbital, that is 1s. So 1s you will be having 2 electrons, maximum of 2 electrons. Next 2s you will be having again 2 electrons, 4 are completed. And this p orbital, as we know, it has maximum, it can fill 6 electrons. I will be telling this. Since it has completed all the electrons, so it has remaining 2. These 2 will be going into 2p orbital. Okay. We don't know where it will go, from 2p to 2p, 2y, 2py, 2px, 2py, 2pz. It may go anywhere, but out of 6 electrons, 2 electrons will be filled, 4 will be empty. Okay, you just note it down. I'll explain this. Okay. Take a screenshot. Now, I'll write down one point. You just note it. Okay. S orbital, S subshell has maximum of 2 electrons, because this S orbital will only, this S subshell will only have one orbital, and you know that one orbital can fill only of 2 electrons. S orbital can fill 2 electrons. P orbital, since it has 3 orbitals, S subshell has 2 or 3 orbitals, px, py and pz. 2, 2, 2, what is 2 plus 2 plus 2? It's 6. So 6 electrons will be having in p orbital, p subshell, and in d subshell you will be having 5 orbitals, right? T, dxy, dyz, dzx, dx square minus y square, dz square. So 5 into 2, that is 10 electrons can be filled maximum here. Similarly, for F subshell, you will be having, okay, F orbital has 3, L value is 3. So since you know that you have orientations ML from minus 2L plus 1 values, so 2 to the 6 plus 1, 7, and each orbital will have 2 electrons, so 7 2s are 14 electrons you will be having. So 14 electrons can be filled, maximum electrons, that is, this is subshell, and this is maximum number of electrons that can be filled in each subshell. S subshell 2 electrons, P subshell 6 electrons, D subshell 10 electrons, F subshell 14 electrons you will be having. Okay. Now, I think you understood it. Okay. So now, exceptional. No, okay. Instead of telling, okay. Exceptional electronic configuration, you will be having some other elements, but mainly in your NCERT, exceptional electronic configuration is given to the 2 elements, that is from atomic number 1 to 30. You will be having exceptional electronic configuration for chromium and chromium and copper, that is Cu. Chromium is represented by Cr and copper is represented by Cu. So from atomic number 1 to 30, you will be having only two elements, that is chromium and copper, which have exceptional electronic configuration. Chromium having atomic number 24 and copper having atomic number 29. Okay, this chromium according to theory, what's the electronic configuration? You can write, I guess, 24. Okay, I need to tell you one more thing. In noble gases, you will be having helium, neon, argon, krypton, xenon, and radon. Okay, better first initial stages, you just learn these three noble gases having atomic numbers 2, 10 and 18. Argon having atomic number 18, neon 10 and helium 2. Okay, instead of writing, suppose helium electron configuration, you can write it as 1s2. Instead of 1s2, you can directly write it as He helium, like this, enclosed in parentheses, square brackets. Okay. Now, instead for neon, you will be having configuration 1s2, 2s2, 2p6, right? 4p6, right? 10. Now, instead of writing this whole configuration, you can write Ne in square brackets. Okay. So in chromium, so it crosses the atomic number 18, so we can write argon, argon. You will be filling till 3p6, 4s2 and 3d4. Okay. So 4 orbitals will be filled in the 3d orbital, 3d subshell. Okay. Argon 18 plus 2 20 plus 4 24. This is the theory, according to theory, but since it is exceptional case, in actual case, what happens is argon, argon 4s1 3d5, and similarly for actual electronic configuration of copper will be similar to this, that is argon atomic number is 29. Here actual EC means EC stands for electronic configuration of chromium of atomic number 24. Here this is 29, so argon 4s2 3d10, this is expected. Okay, sorry, 3d9, this is expected, but this is expected according to theory, but actual electronic configuration of copper is argon 4s1 3d10. What's the reason? I'll tell you behind this. Okay, you just note it down. You need not remember this. It's incorrect. But I am writing for your understanding. You just note it down. Okay, you don't need to remember this theory. You need to only remember the actual things what are happening in exception. See, here actually in real cases you need to write 4s2, but why you are writing 4s1 means you have one rule in there. Okay, I'll write that rule. Half filled and fully filled atomic orbitals, half filled and fully filled atomic orbitals are more stable. Okay, half filled and fully filled atomic orbitals are more stable than others. You need to remember this point. What is it? Half filled and fully filled atomic orbitals are more stable than others. Half filled and fully filled atomic orbitals are more stable than others. What does it mean? See, 3D, this D, since we have 10 electrons in it, see here you are filling in actual case, in theory, according to theory, it should be 3d4 and 4s2, right? What happens is, since 3d5 half filled, in 10 electrons, what is half? It's 5 electrons, okay? Since more than 4, 5 is more stable. Half filled is more stable, so it will borrow one electron from this and it will become more stable. This is also called as pseudo noble gas configurations, which have half filled. Okay. Now Similarly for copper, you'll be having 4:3d9 in theory, according to theory, but it will borrow an electron and it will become 4s1 3d10. This is a stable configuration. You only remember this rule very well. It's a very important question for your JEE and Neet or any other competitive exams. It's very important. Half-filled and fully filled atomic orbitals are more stable than others. Okay, let us also do 1-2 example questions for your better understanding. First, let us see the electronic configuration of chlorine. I written some 30 elements atomic numbers previously in the starting video. So if you don't know the atomic numbers of the elements, atomic number 1 to 30, you just view it. Chlorine atomic number is 70. Okay. Okay. Here, you need to write the configuration. I am giving this question: 1s2, 2s2, 2p6, 3s2. Means how many electrons come here? 2 plus 2 4 plus 6 10 12 and 12. Yeah, it's 70. It's complete. Instead of this, you can write neon. Since neon has atomic number 10 and it's noble gas, neon 3s2 3p5. This like you write like this, and you just write down for manganese Mn. For manganese Mn, atomic number 25 will be I told you that scandium, titanium, vanadium, chromium, manganese. Manganese is similarly, since manganese crossed the noble gas argon, so you can write argon as 4s2 3d5. It will become habit of writing electronic configuration once you complete the D and F block elements in your 12th grade. So it will be very useful thing. Okay, if you want more examples, okay, I'll give you one homework question. I'll give 4 elements. You need to write the electronic configuration and comment me down the answer. Okay. So homework, first element I am giving is zinc. Second element is nitrogen. Third electronic configuration you need to write this phosphorus. Fourth one is iron. You just write down the electronic configuration of this. I will write the atomic number of this as a hint. Atomic number 30. Atomic number of nitrogen is 7. Atomic number of phosphorus is 15. Atomic number of iron is 26. This is a hint. According to this hint, you can do more questions. And also in this exception, you will be having one more element. It's not much important for you at this stage, but platinum PT has exceptional electronic configuration. Just note down this. Platinum has exceptional electronic configuration. You will be seeing later. It's not much worthful question at this stage of first chapter. Okay, just take a screenshot. Okay, I hope you like this video. Share my channel, subscribe, subscribe my channel, like this video, and comment me down all the answers. Okay, kindly understand this very clearly, and from next chapter I will be writing like this and directly explaining you to save your time. And I hope you understood this video. Thank you.